What we are avatars of the One. The One awareness is exploring all of its possibilities through different avatars. So somehow there is this field of awareness that is, in some sense, deeply and fundamentally who you really are.
What do you think about the AI scientists that signed the paper saying that we need to slow AI down because, and I had one of them on the show, because it passed a Turing test faster than they thought, it's just moving faster than they expected, and they're very worried. Do you think that AI will ever become conscious?
I'm actually not too worried about AI right now myself, so I'm not one of the alarmists that says we need to stop and worry about it. The thing that would alarm me more would be if there were some kind of law that criminalized most people from doing it and let a few people do it, a few companies do it. That alarms me. So if there's going to be any kind of laws, they should be universal and no one should be excluded. But
why aren't you worried about AI?
It's pretty easy, even with ChatGPT, to give it questions it can't answer right now. It's basically a good statistical analyzer. It's not deeply intelligent. It will find things that we humans won't find in medical searches, and so forth. But that's because it just can handle more data and do more statistical analysis than we can. But it's not deeply intelligent. And the founders would tell you that. It's fairly straightforward kinds of algorithms. So, and in terms of consciousness, there is no theory right now of any kind that can start with physical systems like circuits, software, and explain even one specific conscious experience, how it arises. So I'll be very, very clear. There's no theory on the planet today that can start with an artificial intelligence and a description of some kind of circuit or some kind of software pattern of activity and can give you a specific conscious experience like the taste of chocolate or the smell of garlic, where you would say this pattern of activity must be identical, must be the taste of chocolate. It could not be the smell of a rose. There's nothing on the table, and there's nothing even close. So if AIs can be conscious, there are no theories right now at all that could explain how that could possibly be, and nothing that makes it even plausible. So I'm not too worried about AIs being conscious. I think that they will eventually outperform humans in most everyday activities, but simply because they'll have more compute power and can search more deeply than we can.
Will, so for people that don't know you, I'm going to give a super brief synopsis, and by all means put in where I go awry here, but you believe that this is all a simulation. We are living in a simulation. None of this is real. Space-time itself is not real. We are effectively living inside of what you call the headset,
Right.
that everything you've ever known or ever experienced is all effectively an illusion. It is a computer video game by way of analogy.
Right.
Given that, and audience listening at home, you will notice he did not say no. So, and this is something I have forever just dismissed out of hand, that we're living in a simulation. And I say dismissed out of hand because I don't have any evidence to back it up. And I've heard all the arguments from a mathematical perspective that if you believe that humans are capable of creating photorealistic simulations, and you give any rate of progress whatsoever, we will eventually create a simulation. We certainly, with AI and how rapidly it's been advancing, I think people now really have a sense of, whoa, we really are going to be able to do this. Apple Vision Pro certainly gives an indication like you will really be able to create some very compelling, very realistic things inside of a visor. So I think people more than ever could see how we could get into a simulation, a simulated world that's convincing. I'll leave it at that. And if that's true, then why would we then, once we create that simulation, not create another simulation? And I will just tell you, as somebody, the t-shirt that I'm wearing is literally about this. We're building a game that we hope over time will be a truly simulated world, that people will go in, they will have an identity inside that game. Okay, so if we know that loop exists, then once the game inside the game gets powerful enough, it will do another simulation. Once the game inside that game gets powerful enough, it will do a simulation. And so you end up in this point where just mathematically, it would make more sense to believe that you're in one of those, conceivably infinite recursive loops of a simulation than that you're in base reality. But it just always seemed weird to me to say, no, we're in one of the simulations. But the more I research you, the more I'm like, maybe we really are in a simulation. And to that point, you talk about consciousness as being fundamental. And so I'll need you to explain that for people that will be so jarring. It will take them a while to really grok that. But that consciousness is fundamental. So couldn't AI ever become a window into what you call a conscious agent in the same way that a human child is, or a dog is, or whatever?
That I think is possible. Absolutely. So
if you don't mind, walk people through how it could be possible that physicality, everything they see, touch, taste, the loves that they have, all of that is a simulation and not fundamental, meaning it arises out of something else. But consciousness is the
fundamental.
The foundation.
Well, there are two arguments for the idea that what we see is not an objective reality that exists independent of us and is there prior to when we look at it. So in physics, the Nobel Prize last December was given to 3 physicists for the experimental testing of a clean prediction of quantum theory that something called local realism is false. Local realism is the claim that physical objects like electrons have definite, so realism is the claim that an electron has a definite value of position, momentum, and spin when it's not observed. And locality is the claim that those properties have influences that propagate through space-time no faster than the speed of light. And the conjunction of those two claims, the properties exist even when they're not perceived, even when they're not measured, and they have influences that propagate no faster than the speed of light, that's local realism, and local realism is false.
How did they prove it?
So that's why you get a Nobel Prize. So John Clauser, Anton Zeilinger, and Alan Aspect, over decades, there's a string of experiments that were tighter and tighter. Each experiment closed loopholes in the previous ones. So the experiments have to deal with, they're complicated experiments. I mean, Zeilinger was actually using photons from outer space to get entangled particles that he could use that you couldn't argue that they were somehow being connected or correlated in some deep way. But basically, the experiments are set up to show that properties like position or momentum or spin, typically they like to use spin, in principle could not have definite values until you actually measured them. So one way that they do this mathematically are there these Bell inequalities. And so if the statistics of the correlations between the particle spins, you have 2 different particles that you're measuring the spin axis, for example. And if they had definite values, even when you weren't observing, you'd have certain pattern of correlation. And if quantum mechanics is right, and those values don't exist until you measure them, then you have a different pattern of correlation. And so that's what they do. They have to look at a bunch of different measurements, look at the correlations, and the correlations come out to be what quantum theory predicts, and not what our classical intuitions would tell us. And so this was done by Clauser decades ago, but it's so counterintuitive that people were going, okay, well, there must be a loophole here. So then they closed a series of loopholes. And finally, they started getting photons from like distant galaxies where the photons couldn't possibly have certain within space-time causal connections, and closed that loophole. And so that's one direction. So physicists tell us that local realism, at least for microscopic, subatomic particles. Recently, they've gotten up to groups of 700 atoms, I believe. So it's starting to. They're showing that these effects, the superposition effects of quantum theory, are not just at the very, very small end of things. So local realism is false. Now, one can still try to say, well, but that's for really tiny things, but at the macroscopic level, maybe local realism is true. And that leads to a problem because there's no principal distinction in quantum theory between the microscopic and the macro. You can't say at 10 to the minus 20 centimeters, that's That's the limit. There's no boundary between micro and macro. So, and this is a well-known open problem. So that's one direction. I'll just go with that. Now, the other direction of argument is from evolution by natural selection, where you can ask a technical question. Evolution shapes sensory systems to guide adaptive behavior. So that means to keep you alive long enough to reproduce, right? So you have vision and touch and hearing and smell, and they've been shaped so that you're able to get the food you need, mate, and stay alive at least long enough to reproduce and pass your genes on to the next generation. That's the standard story of evolution. Many theorists also think that evolution shapes our sensory systems to tell us truths about objective reality. Like, when I see an apple, that's because there really is an apple, and the red color and the shape really exist, even when they're not perceived. And so notice that's a step beyond just saying that our senses evolved to guide adaptive behavior. They want to say more than that. They want to say that if you guide adaptive behavior, you're going to see the truth. So I decided with my colleagues, Chetan Prakash and Manish Singh and Robert Prentner and others, my graduate students, Justin Mark and Brian Marion, to test this. Evolution is a mathematically precise theory. We have evolutionary game theory. So there's a technical question. What is the probability that evolution by natural selection would shape any sensory system to see truths about objective reality, the structure of objective reality? And it's straightforward to prove. What we do is we look at various kinds of so-called fitness payoff functions. Maybe payoff functions that are, and we can ask, do these payoff functions preserve certain kinds of structures in the world, like orders, a total order, or a partial order, or a metric, or a topology, or a measurable structure. So we can say, we don't know what objective reality is, but suppose it had this structure. What is the probability that fitness payoffs, which govern our evolution, would actually have information about that structure in the world so that we could actually be evolved to have some insight into that structure of objective reality? And in case after case, the answer is probability is zero. There are payoff functions that would preserve the structure, but those payoff functions have probability zero in the set of all payoff functions. So that means if you're a betting man, you would bet long odds against it. So it doesn't mean that it can't happen, it's just that the probability is zero. And so I take this as a convergence between two of our big theories in science, evolution by natural selection and quantum theory, quantum field theory. Both are telling us that local realism is false. And so I think a good metaphor then is, as you were saying, like a user interface or a video game where you render on the fly what you need. So I'm looking at you, I'm rendering a Tom face, and I look away and I'm not rendering it. Someone else might be looking at you and they're rendering their Tom face, but their Tom face is not the same as mine. It's going to be at a different angle and so forth. So we render on the fly, and that's what physics is telling us basically, that local realism is false. We render on the fly.
And so where you're taking that from is the quantum uncertainty principle, basically. Everything has a probability of being in a given state. And the reason that it's just a big question mark is because nothing's looking at it. So it does not need to render that. It doesn't need to decide. The system, which is the simulation, which people think of as space-time, but they're almost certainly, I've interviewed you so many times and I know how hard it is to escape this matrix, but they're thinking of things within space-time being real. But once you start looking at space-time as purely a simulation, and that the then rendering only happens when you look at something. So that to me makes a hypothesis that I think your data backs up, which if that were really the case, then I understand why big things would adhere to what seem like a different set of rules where things are static and small things would not, because you're far less likely to observe a first order consequence of something microscopic. You may be observing a second or third order consequence, which raises questions for me that I'm sure we will get to at some point. But just to close the loop on that. So first order consequence, I can look up and see the moon. I see planets, I see stars. And so for that to be persistent, which is going to be a big thing in our discussion today, this is like the prime thing I want to talk to you about is persistence and what that means. But big things will need to be persistent. And therefore, there is a constant collapsing of its probabilities because there are so many things that require, even if it's just its effects on gravity, there's so many things, quote unquote, witnessing that or measuring that. So I get why those would be stable. But then things where they're so small that there's very little that hinges on that would need to be directly rendered. That would need to, because you can get away with sort of the probabilistic rendering of the big things and their influence by these smaller things, but you don't need a direct representation of the spin, for instance, of a particle that all things that will quote unquote measure it don't see, don't interact with, or whatever, because nobody's effectively looking at it. It does not need to be rendered.
Right. So a good. So
did that all feel right? Just to
no, that's a great question, and so
great question. I was not asking a question. I was stating a hypothesis.
About
Do you think I'm crazy, or
no? I think
does that make sense at the macro to the micro level?
Well, it does, but I think a good analogy here that might help clarify the issue is so in, say, Grand Theft Auto, right? I look over. I'm playing with somebody who's in Canada, and somebody else is in Europe, and someone else is in China. We're all playing a remote version of it in virtual reality. And I look over and I see a red Porsche to my right. And so I say, is there a red Porsche on my right? And the guy in China says, oh yeah, I see a red Porsche. And the guy in Canada agrees, and the guy in Europe agrees as well. So of course, each of them is rendering their own red Porsche. So there is some reality that's coordinating all of these perceptions, right? So the guy in Canada didn't see a red Porsche until he looked. But when he looked, there was this whole world, of circuits and software that you don't see. There's some supercomputer that's coordinating the whole thing.
How's it coordinating?
In that particular metaphor, right? There's a supercomputer that's taking the inputs from like your headset. What direction are you looking with your headset? Maybe you've got a bodysuit, so it's looking at your arm movements and so forth, and it's feeding all that into a supercomputer, where it's got a model of the game. And in that model, there's some red Porsche model. Of course, there's no red Porsche in the computer. And it knows then how to coordinate and send the photons to your headset in Canada and my headset in Irvine and someone else's headset in China, so that we have this notion of a persistent reality of a Porsche, even though individually, for each one of us, local realism is false. The Porsche doesn't even exist until I render it. And there's no red Porsche inside the supercomputer. So that's sort of the idea, is that space-time is just a headset, and there's behind space-time, there's going to be an incredibly complicated realm to explore that's at least as complicated, more complicated as like the supercomputer is to my little headset. The headset is sophisticated, it's beautiful technology, but the supercomputer is really, really powerful thing. And the same thing will be true of space-time. It's just our headset, but if we look beyond that headset, we're going to be finding a realm that's far more complicated. So in some sense, science, up till now, has only studied our headset. We've studied inside space and time. We're taking our first baby steps to start to explore. We've cut our teeth in science on studying our headset. We learned the tools in the last 300 or 400 years about experiments and clean mathematical theories and the loop between experiments and theories. But we thought we were studying objective reality. We were studying our headset. But now we have the tools to actually take a first step beyond space-time and start to find structures beyond space-time and their projection back into space-time. And so from that point of view, our view that objects in space-time, we've taken that to be the fundamental reality, will look sort of parochial, hopefully in just a few decades. I think the next generation, where many people will have spent a lot of time in virtual reality. My generation didn't spend a lot of time in virtual reality, so this is a hard concept. But if you've spent...
I've heard you say that before. I don't think that's going to get people where you think it's going to get them.
Maybe not.
But in this episode, I want to try to explain why I think that and get your take. So here's what I think we need to do first, and then we'll go even deeper. There's two things we need to do in the near term. One, I think we need to, in our previous interviews, we spent a lot of time dealing with the headset. So for anybody that's sort of confused on that idea of you're living in a simulation, everything that you know and love and touch and have ever experienced, it is all a simulation. You have never existed outside of the headset. So if right there your brain breaks, go watch the other episodes. We spend a tremendous amount of time building that up.
Right.
But for now, what I want to do is say, okay, I'm going to assume that you get it, that your whole life is basically Grand Theft Auto.
Okay.
And people understand it. You've been in there playing the game, and they understand the difference between playing the game and the computer rules and things that give birth to that game. And so that's the difference. What I want to do now is map that one layer back. So I want to take that idea of your life is Grand Theft Auto, but there's this thing called space-time that's outside of it, and get to what you're actually saying, which is that same relationship, but move back one very profound level. Because what it does is it inverts everything. And what it says is that the universe, space-time, is an emergent phenomenon from consciousness. That consciousness is in this, to use that analogy, just to map it back, that consciousness is the quote unquote computer and rules of the system. And then the simulation is what we all think of as real life. Okay, so that's where we're mapping. So
Right,
one, does that track for you, that we can move that analogy sort of one rung deeper is probably the word you'd be most comfortable with?
Right. So absolutely, a model in which we take consciousness as fundamental, and we have a mathematical model of consciousness, and we then try to show how space-time gets rendered from that. Absolutely.
Okay, perfect.
You can reboot your life, your health, even your career, anything you want. All you need is discipline. I can teach you the tactics that I learned while growing a billion-dollar business that will allow you to see your goals through. Whether you want better health, stronger relationships, a more successful career, any of that is possible with the mindset and business programs in Impact Theory University. Join the thousands of students who have already accomplished amazing things. Tap now for a free trial and get started today.
So now in this interview, instead of making our references to Grand Theft Auto, unless we need to for whatever, for an anchor point, I want to talk about space-time
Okay.
like a simulation.
Okay,
I want to talk about space-time like it is Grand Theft Auto, because researching you this time, I want to sit with it for a while before I start saying I'm 100% behind it. And I mentioned in one of our previous interviews that I do revert to the mean after I spend time with you, but each time you're shifting me farther where my mean is sort of closer to you. Mm-hmm. This time, at least in the research, I had a real sense of he's right. I don't know about the consciousness is the only part that we may disagree,
Sure.
but that you really gave me an internally consistent set of logic points for why space-time is the simulation. And when I grant you a few base assumptions that we'll go through, my own worldview makes more sense.
Okay.
And so I realized for the first time, again, fully acknowledging that I may revert to the mean once I've interviewed 3 or 4 other people on totally different topics, and this is sort of cleared my system. But right now, as we do this, I really felt like you improved what I consider a prediction engine. I think of the human mind as a prediction engine, and the closer you get to baseline truth, the more you're able to predict the outcome of your behaviors. What I'm watching happening with AI, which is why I wanted to start there, I can't make sense. When I think about a hallucinating AI, I'm like, I don't understand. When I think about AI pulling patterns out of noise, I don't understand. When persistence is difficult for AI, I don't understand. And then I research you, and click, click, click. Those pieces fall into place when I assume that it's all already a simulation and that AI is simply revealing to me how the simulation works. And so, but the fact that we disagree, or maybe we don't, I think AI will be windows into consciousness. I think AI is leveraging your own theories to create AI right now as we're talking about it. I think, I'm a lay person, everybody needs to take this with a huge grain of salt. Trust me, I am well aware of my limitations. But I think right now that what we're witnessing with things like Stable Diffusion, where AI is creating an image out of the infinite possibilities that exist within the possibility space of noise. Okay, for people that don't understand how Stable Diffusion works, that's how it works. Is it dips into the noise to find a pattern and then solidifies that pattern to reveal, is this what you wanted? And what I'm saying is when I research you, I realize, oh my God, that's precisely what your theory predicts. in the idea of Gödel's incompleteness theorem, which I have struggled with so hard in the previous interviews. I feel bad for everybody that has to watch me go through that. But the more I feel like I can grasp why you keep coming back to it and why this sort of infinite possibility space is so important to understand, when I watch AI pull a static image out of infinite possibility, I'm like, oh my God, that's exactly what you've been trying to describe. Okay, put a pin in that,
Okay.
because what I want to talk about now is consciousness as fundamental. Because this is the part, if people are really paying attention, this is the part that will change your worldview. To get into the space-time as a construct, as a simulation, you first have to understand that you think that's born of consciousness itself. And please, dear audience, stick with this, because this point is going to be very important as we piece together the predictions that your own model is going to make. But they have to understand this first. So how is it possible that consciousness, the thing that I think everybody intuits, comes from stacking neurons, and you pass through a cricket, an ant, a mouse, a cat, a dog, a dolphin, a gorilla, and humans. It just feels like, just stack more neurons. And then you're ultimately going to get these more sophisticated neurons, which give you a more sophisticated consciousness. That seems so self-evident. And you're, to me, but you're saying, nope.
No. And by the way, I'll just mention that I agree with you that AIs could actually give us a window into consciousness, but they won't create consciousness. That was all I was saying.
Interesting.
So
I think we disagree about that.
okay. So
But you're
so
so
we can
much
go
more
into that.
thoughtful
Okay.
and so much farther ahead. When we get there, I will
Yeah,
lay out my
absolutely. Okay.
ignorant perspective.
So on consciousness being fundamental,
Meaning that's all there is.
that's right. So the idea would be, and this is, by the way, in some sense, not new. Leibniz, in his monadology, had the same idea. So
I really appreciate that you assume I know what that means. And from context, I can tease it out. But can you tell us what that means?
so Leibniz was this genius, contemporary of Newton, sort of a antagonistic. They both invented calculus at roughly the same time. There was a question about who was first and so forth, and they were sort of at each other, but they were contemporaries. But Leibniz had this idea that consciousness couldn't emerge from physical systems. He has a famous argument of the mill, where he in one paragraph basically dismisses the idea that objects inside space and time, like neurons, for example, could create consciousness. For him, it was so obvious that he spent a paragraph on it and moved on. And then he's got a book called The Monadology, where he was proposing essentially that consciousness, perceiving entities, are the fundamental reality, and that they were interacting.
All right, if I break down the words monadology,
Monad, so MONAD is a
Monad.
technical term for
Got
him.
it.
It was a new term for him. Monadology is then the book's name, Monadology, and it was basically, it was a dynamics. It was a strange dynamics we called a pre-established harmony, where God. So he brought God in on his thing, I believe, to sort of coordinate all the perceptions of these. So
meaning God was the first mover, the
yeah,
fundamental.
the fundamental,
thing.
right?
Okay, but he saw it as a creator,
Right.
touching things with like a divine spark of consciousness.
Yeah, but his ontology was that the fundamental reality beyond space-time was these monads, these perceiving entities, basically. And but God, I think, was the deepest reality for Leibniz. There, I'm less secure. The I'm not sure exactly what his thoughts were on God, but I believe that's what he said. So I just brought that up just to say that we're not the first to have this kind of idea. Centuries ago, Leibniz, with his monadology, had an idea that perceiving entities, experiencing entities, could be more fundamental than the physical space-time world.
All right, you talk about conscious agents.
Right.
Do you mean exactly that same thing?
That's right. So conscious agents are a mathematically precise statement of what we mean by consciousness, right? So as a scientist, it's not enough for me just to say, okay, there's consciousness beyond space-time and it's fundamental. I have to write down a mathematical description of what I mean by that. So what aspect of consciousness do I take to be fundamental, and what's the mathematical description? So if you think about it, when you think about consciousness, there's of course experiences, there's learning, memory, problem solving, intelligence, maybe free will. There's lots of things, the notion of a self, all these things that you might think a theory of consciousness needs to incorporate.
I'm so sorry, and I should have done this before, and that apology goes to the audience. If you're new to Donald, it's probably worth just a quick sentence about what consciousness is.
Oh, well, so I would say consciousness is the ability to have experiences, like the taste of chocolate, a headache, emotions.
So this thing feels like something.
Yeah, the way a lot of philosophers will talk about it is to have conscious experience. There's something it's like to be a conscious entity. There's something it's like to have a headache. There's something it's like to have your, to have a nice cup of coffee or something like that.
Okay, and so let's call that qualia. Again,
That's
me
right.
stealing directly from you.
Right.
But just so we have words, because qualia is going to become very important as we get into your paper and all of that. Okay, so back to conscious agents.
So what we decided to do was we don't want to throw the kitchen sink in our mathematical definition. So we took what we felt was the bare minimum starting point. There are experiences like the taste of chocolate, smell of garlic, and so forth. And those experiences affect the probabilities of other experiences occurring. So there are experiences and probabilistic relationships among experiences. That's it. So we're not bringing in the notion of a self, learning, memory, problem solving, intelligence, none of that. What we're saying is, yeah, all that stuff is important, but we have to prove how it arises from just experiences and probabilistic relationships among experiences. Mm-hmm. So that's, as a scientist, you try, it's what we call Occam's razor. You want to have the minimum number of assumptions at the start of your theory. Every theory has assumptions. There are the miracles of the theory. We want as few miracles as possible, right? So our only miracles are, it's a big miracle. There are experiences and probabilistic relationships among experiences. And we formalize that. The experiences, we just write down what's called probability spaces. We can, if you want, we can talk about probability spaces. And the relationships among experiences are what we call Markovian kernels. And we get what's called Markov chains. So it's very simple dynamics.
So we'll explain what Markovian dynamics are in a second. Now that I finally have at least a tiny bit of a grasp, I don't know how important it is that people understand that.
Sure.
But I do want to know, how important is it that one bit of qualia impacts other qualia? Like, does that relationship play heavily into the idea of consciousness as a fundamental agent?
Yes, we stipulate that as a fundamental property that experiences aren't in a vacuum. Experiences probabilistically lead to other experiences.
Okay. It's very interesting that you said not in a vacuum, because my whole thesis is that the construct of space-time, the simulation, let's just be very clear, the simulation that is this real world, sorry, that's a terrible use of the word real, the simulation that everybody lives in and experiences is required, this is my pitch, the simulation is a required constraint in order to give context that something can be like anything, but that for consciousness to explore the possibility space of qualia, you have to have a rule set. Mm-hmm. And the rule set that we're all in, which may be one of a gazillion headsets, but the rule set that we're all in creates the possibility for the subset of qualia that we as human beings or lizards or whatever experience. But without that rule set that is space-time, we would not have enough limitations to give us the context in order to feel a certain way.
Exactly. That's a very good way to put it. So that a lizard presumably sees things very, very differently than I do. Pigeons have 4 color receptors. We only have 3.
Pigeons have 4?
Yeah, that's right. So they see more color than we do. Birds.
Some bullshit. I feel cheated now. Pigeons?
Well,
I knew 15% of women do. I did not know pigeons.
Yeah, the mantis shrimp has more than 10.
Photoreceptors?
Yes, that's right. Different kinds of or pigments that are used for the photoreception process. So
Crazy.
so we may be cheated in many ways.
That is for sure.
So yeah, we and we don't, for example, perceive polarization of light, and birds and maybe bees do, as they can perceive the polarization of light. We can't directly experience electric fields, and there are animals in the water that can do that. So some that see infrared, some that see ultraviolet that we can't. So we have a very small window, and other animals are not restricted to the windows in which we see. So I like your idea that there's an infinite space of conscious experiences to explore, and when we look at different animals, we're seeing different explorations with different headsets, and different, as you say, different constraints, and it's in some sense consciousness exploring all of its possibilities, all the possible ways that to explore. So in some sense, we're here for the ride, and we should enjoy the ride. We're exploring. We thought this was the final reality. No, this is just one of countless possible headsets, just one of countless, and we'll enjoy this ride, and then consciousness will then it's looking through other headsets. So I like your idea. Yeah, that it's there's some kind of consistency, some kind of coherence, but it's a subset of the experiences. There's an infinite number of experiences to explore. So this ride never ends.
Okay, so when I think about consciousness as fundamental, I cannot help but imagine a blob that then takes shape in the form of a human or a lizard or an avocado, whatever. Help me understand do you have an image in your head of what consciousness is? Is it just completely non-physical?
Well, maybe the closest I can get that would be a way that would communicate to people would be if you go into an entirely quiet room, shut off all the lights, close your eyes, and get very still, and don't think.
Good luck.
That's right. Usually letting go of thought is not easy, but if you can go for a few seconds or a minute with absolutely no thought, and now you're just aware, you realize, yeah, I can be aware without being aware of anything in particular. I am fundamentally awareness. And into that awareness right now are coming a cup, a microphone, a table. I can close my eyes and those are gone from awareness. So somehow there is this field of awareness that is, in some sense, deeply and fundamentally who you really are. It
seems like your theory would say that's false.
Well, it's going to say that the reason why I talk about this awareness is that when we talk about all these specific conscious experiences, we have to write down something that's called a probability space. First, we're required mathematically to do that. So we write down a probability space in which
probability of qualia.
That's right. Probability of qualia. So you have to write down the space of all the potential qualia that this particular conscious agent could experience. So here is this space, and there's the mathematical structure. It's just sitting there prior to any particular experience happening. It's just sitting there. And it took me a few years to ask myself the question, what is that space? I had to write it down. I couldn't do the math. I couldn't write down my Markovian dynamics until I wrote down the probability spaces. But the way we do it is we just, of course, have to write that down, so you don't even think about it. You write down the probability space, and you go on to the fun stuff. You write down now the dynamics and so forth. But a few years later, I came back and go, well, wait a minute. I went too quickly on this first part. I had to write down a probability space. What does that mean? Because this is a space prior to any specific conscious experiences happening. And so the best I can say right now is that perhaps is the mathematical counterpart to what I was just describing, which is the awareness that you can experience prior to having any particular specific conscious experience arise in that awareness. So that's why I talk about it in that way.
Can I just restate that to make sure that I understand and linger on it for a second for the audience? So you're using words that I know you know are dangerous, that Annaka Harris has warned you about letting people carry the sense of self into all this.
Right.
Because you said you are the awareness, but really consciousness is the awareness that animates me in some way, or it needs my constraints in order for it to experience the qualia. I think that's the right way to think about it. And so in those moments where either through meditation, I get to where I am simply aware of the qualia of being aware, but when it's not aware of anything in particular, so I'm not aware that my foot hurts. I'm not aware that my stomach is churning on food. I'm not aware of something I need to do later in that day. I am just the potential to point that awareness at something is the thing that I'm sitting in. That's who we really are. So that feels right, but I know it's re-trapping me in my sense of self that I am a real thing. Your whole thing clicks into place for me when I realize that according to your theory, and this makes a lot of things make sense in my own life, I am simply one instantiation that creates a set of what I call biological limitations that then once I have those constraints, now the fundamental element of consciousness can begin to explore its qualia. The different things that like, oh, in this human form, I can experience these things. And with all the context that this person has, he responds to this thing in this way.
Right. Agreed.
There are some deep complexities with that, but we'll push those off for later. Okay, so if that's where we're at, my fundamental question is, why is it compelled to explore these qualia states?
That's the $64,000 question. So I don't know, but I'm of course, that's the very natural question to ask. And I agree with what you just said. I mean, I don't want to reify the self. What we are avatars of the one, effectively. And the one consciousness is, the one awareness is exploring all of its possibilities through different avatars. Why? I think there may be some deep mathematical reasons. So it may be that, there are theorems to the effect that no system can completely know itself. It's impossible. So, because, for example, if I have a computer and I want the computer to explore itself, how is it going to know itself? Well, it's going to have to build a model of itself and write down in the very process of building a model of itself and writing into its memory things about itself, it's becoming more complicated. It's changing itself. So now, to really understand itself, it's going to have to now describe what it just did. And now so you get this infinite loop. And so there are problems with self-understanding. It's not possible, in many cases, provably not possible, to have a complete understanding of yourself. You get into this infinite loop of, now I have to be more complicated to understand myself after I just understood myself, right? And so that's one direction of this. Another direction is there's a whole hierarchy of infinities. So the integers, like, so 1, 2, 3 up to infinity, that's an infinite number of integers. We call that a countable infinity, or Aleph 0, the Hebrew letter Aleph, and 0 just meaning the smallest infinity. But there are other infinities. So if you take the set of all subsets of integers, so like 1, 2, and 1, 5, and 2, 3, 4, look at all the possible subsets of integers and ask, how many subsets are there? How many subsets of integers can you come up with? It turns out that, of course, there's an infinite number of these subsets.
Because every number is divisible by an infinite number of slices?
No, we're just grouping them together. So I'm saying, think about the group 1 and 2. So that's a group. now 1 and 5.
Got it. So we can group an infinite number of times.
So those are called all the different possible subsets of the integers.
Got it.
And there's, of course, an infinite number of them because 1 is a group, 2 is a group, 3. So we already know there's an infinite number, but there's more than that. How much more? It turns out it's a bigger infinity. So
it's a bigger infinity.
It's a bigger.
Say what?
That's what mathematicians said when Cantor, the mathematician who first came up with this, when he first proved this.
This feels a bit like my speaker goes to 11. Why not just make 10 louder? But this one goes.
This
to
one
11.
goes. It's actually a different size of infinity, and
How's
so
that possible? I literally can't wrap my head around that.
there is something called Cantor's diagonal argument. So there's a simple diagonal argument where you can actually show on paper, pen and paper, that it's impossible to capture all the power set, this bigger infinity, with the smaller infinity. So he gives what's called Cantor's diagonal. So if people want to check me on this, you just look up Cantor and Cantor's diagonal argument for a proof that there are these bigger infinities. And you can actually, I think most people can actually follow the proof. I mean, it's mind-bending, but you can follow it. Well, there's not just one bigger infinity. That's Aleph 1, is the bigger infinity. Now, take the power set. So, by the way, taking the set of all subsets is called taking the power set. So the power set is all the possible subsets. So now I've got Aleph 1, which is the bigger infinity, which is all the power sets of Aleph 0. But now I can take all the power set of Aleph 1. That gives me Aleph 2. Take the power set again at Aleph 3, Aleph 4, and this goes forever. So infinity is not one thing. There's an infinite, unending hierarchy of ever larger infinities. So we have to, my view, take this into account in our theory of consciousness, that all of these different infinities are valid directions for projection of this one deeper consciousness. And so so the answer to your question may again be, because Cantor's hierarchy never ends, this exploration never ends. The exploration of the possibilities of consciousness, of qualia, is in principle never ending. So,
I get the never ending
but again, I would just say, I'm in deep water here and I'm maybe over my head.
Fair enough. This is the fun part of exploring this is what are the predictions that are made based on the hypothesis, right? So every hypothesis makes a prediction and then you have something you can test and it becomes verifiable.
Right.
So this is where it gets very interesting to me is what the predictions are that it makes. So going back to the hypothesis that I have that, okay, maybe this really is all a simulation because as we go to build the next simulation, it actually tells us more. It gives me a better way to understand what's already happening. Now, again, I'm a layperson, so I may be way out of my own depth here, but I think people will be able to follow the internal logic. So this is what I was stating earlier about AI. So the way that AI works is there is an infinite possibility space in noise. So you can just think of it as a screen. And that screen can think of every conceivable pixel that's there. And depending on what color you make any one of those pixels, if you have like a grand enough resolution, meaning enough pixels in a finite space, that you can recreate any image that's ever been seen or created or even just what's possible. So if anybody's seen what they call an AI hallucination, where the AI will just continually like push into itself, and every time it pushes in and a pattern begins to emerge, it then crystallizes that pattern and basically says the most likely shape to emerge out of this would be a staircase. But as you push in, the most likely shape to emerge out of that would be a cathedral. And it just keeps going and going and going and going. And it never runs out of sort of most likely things to emerge out of this pattern because it's looked at all of these things. And so it will create things that it's seen before. So the Mona Lisa would be one representation that is very predictable, especially given how many times the Mona Lisa has been replicated. So one of the things in the possibility space is the Mona Lisa, is a Rembrandt, is David, is you looking at your wife this morning is one of the possibility spaces that it could eventually draw out of this thing. So it's constantly searching for what is the next potential pattern. Now, my whole thing is, what really starts to make this interesting, and the reason that I think that the simulation isn't something to be brushed aside as being trivial, but is critically important if you're right that what consciousness is doing is it has some motivation for some reason that neither of us know why, but that it is cycling through all of its permutations. If that's what's really happening, then to do that, you need a set of rules. And so what I realize is I'm building going back to the Grand Theft Auto. So we're building a simulated world. And I realize as we build it, all I'm doing is making the most detailed if this, then that statements. And so I'm trying to create these algorithms that then not trick you, but they give you a set of rules by which you now must adhere. But by doing that, by actually limiting the possibility space, I can make a game that's quote unquote fun. So it is in the limitation, it's in the setting of rules that this becomes a useful space. So what I want to know is you talk a lot about like, hey, we want to get out of the headset. Do you really? Do you want to get out of the headset? Or do you want to manipulate the headset?
Well, when I say we want to get out of the headset, that's as a scientist trying to look for a deeper theory. So as a scientist, I mean, science is...
But let me ask you, so the reason that Einstein, his breakthroughs were so useful is within the headset, they let us do something. Are you trying to do something in the headset? Or so if you understand how the headset works, you can either manipulate like Einstein, bend space-time, right? You can create GPS, which if you didn't understand relativity, you would not be able to do. And that made the atom bomb possible. It made nuclear energy possible. It made GPS possible, his breakthroughs. Are you trying to do a breakthrough that has headset implications? Or are you searching a breakthrough that has get out of the headset implications?
Both. So what I want to do is get a theory of what's beyond, at least a baby step beyond the headset. Presumably, as I mentioned, there's a Cantor's hierarchy of infinity. So we have infinite job security going beyond the headset. It's literally an unending job. But to take a step entirely outside of the headset, then as you point out, as a scientist, I need to make predictions back in the headset because that's the only place we can do experiments.
To prove that you're right, basically.
Well, you can never prove that you're right, but to sort of what we'd say, scientists would say, to get confirmation of your theories, which is not proof, but to say you're not stupid. You seem to be on a good track.
It predicts the things that we already understand.
That's right.
And hopefully makes novel predictions about things that we don't currently understand.
That's right. We should be able to get quantum field theory back as a special case. We get Einstein's theory of general relativity as a special case, evolution by natural selection as a special case. Or generalizations of these theories within space-time. So yes, we're going for the first baby step outside of space-time in terms of a scientific theory. But of course, we have to project it back into space-time where we can do experiments and a better look like evolution by natural selection and quantum field theory, or understandable generalizations of those theories, or we're wrong. Right, so you might say, well, yeah, if you go outside of space-time, you can do anything. You have all the fun you want. You can do anything you want to. No, you can't. You need to tie it back to what we can perceive inside our headset. So that's where we're headed. But as I said, there's infinite job security, and so I view myself as just looking for a first baby step outside of the headset. Science for centuries has only studied our headset because space-time is our headset. But in the last 10 years, physics has gone beyond. We've talked before about the amplituhedron and decorated permutations and other structures that physicists are finding. These are not the final word. Again, these are the first baby steps outside of our headset. And they will be, of course, refined and eventually superseded.
All right, so there's one of these things that I think I've grasped enough that I can present it to people as one of the first baby steps. So in physics, one of the things they're constantly doing is smashing particles together to try to see what happens when those particles collide in the hopes that it will reveal smaller and smaller elements of the building blocks of the universe, which will then help us understand what the sort of fundamental makeup of space-time is. And as they look at this data, what they found is that there are patterns in that data that replicate endlessly. And you smash these together, and the collisions, there's so much data. At first, it seems impossible. Just so much data to wade through. We'll never understand anything. And then all of a sudden you realize, wait, there's only so many patterns once you take those, like once you group those shatters. Like if you think of it this way, if every time you broke a mirror, it broke into the same pattern, you'd be like, wait a second. And am I understanding it correctly that that's what happens when you collide particles?
Statistically, yes, right. So it's not exactly, but you can use statistics to show that there are these statistical commonalities to the interactions. Absolutely.
Okay, walk us through that, and why does that matter?
Well, for physicists, of course, this is some of their most fundamental data. So what are particles? Particles, Eugene Wigner taught us, are what he called irreducible representations, unitary representations of the group of symmetries of space-time, what they call the Poincare group. Essentially, particles are like the simplest things allowed by the symmetries of space-time, the simplest entities allowed. And so in some sense, by studying these particles, we're really studying the nature of space-time itself and the structure of space-time. And so when they, for example, in the Large Hadron Collider, they will smash protons together, or they will they'll also sometimes have an electron and smash it into a proton at high energies. And when you do that at high enough energies, you destroy the proton. It actually falls apart, and you see all these particles scattering out, things like quarks and gluons and mesons and so forth. And so you can look at the angles that these particles are spraying out at, and look at, for example, do they have a spin, a magnetic charge? Do they have a mass? So you can look at all the, and then when you start looking at all the data, you begin to see patterns in the data, and so we see, for example, it was a big surprise to physicists that inside the proton there were these things that they now call quarks. But the quarks, in some sense, at least at the energies that are available to us, can't be on their own. You can't have like quarks flying out on their own. There's something called quark confinement. And that was a big, big discovery. So quarks, like in a proton, there are 3 quarks, 2 up and 1 down. A neutron has 2 down and 1 up. But if the quark escapes, it's trying to get away, the force of attraction between 2 quarks grows with the distance. And the energy, the force doesn't grow, the energy. So the force doesn't, normally we think of the force, so the force doesn't grow, the force remains constant. And so the energy, the potential energy, it keeps growing and growing as you move these particles apart. And so at some point, they snap, and you create all that energy goes and creates a new quark, say. So then they pair off. So it's very, very strange, this quark confinement thing. So one reason we do experiments is because, who ordered that? We wouldn't have guessed, quark confinement. And so, but we found quark confinement, and it's still being studied. Trying to understand that. There's a theory that if we get at really, really high energies, they won't be confined. But those are energies that we currently are nowhere near. And we have no analytic proof right now of quark confinement for what are called non-abelian gauge theories. So one of the big open questions in physics is to actually prove this analytically. So they have lattice gauge models that of this that show it, and they have other cases where the experiments and the theory convince them it's the truth, but we don't actually have the final analytic proof of this in what's called non-abelian gauge theories. So that's still an interesting open question. But that's why physicists are doing this. These particles are really probing, in some sense, the fundamental nature of space-time itself. And so they look at patterns. They look at the cross-sections for interactions. So this was, for example, way back in the early studying of the atom, so there was a plum pudding model of the atom, right? So there was electrons were these negative point particles inside a positive field. And then this one experimenter started shooting particles at atoms. And the Plum model would say that most of these particles would just go straight through. And most of them did. But every once in a while, one would bounce back. A very, very small percentage of the time. And so that gave them the idea, okay, there are point-like particles. We now call them protons and neutrons. These particles that they were hitting, but they were a very, very small space within the atom. So the atom was mostly empty space. The electrons were way far away, so to speak, from the much smaller protons and neutrons. And so, but then we look inside the protons and we find that the proton itself and the neutrons are composed of even smaller particles, quarks and gluons and so forth. And who knows, even the quarks and gluons might be composed of smaller particles, but we don't have the resolution in our colliders right now to test that. We can only go to, a thousandth or 10,000th the diameter of a proton, I think. And at that resolution, the quarks and gluons still look like point-like particles.
What's up, guys? It's Tom Bilyeu, and if you're anything like me, you're always looking for ways to level up your mindset, your business, and your life in general. That's exactly why I started Impact Theory, a podcast that brings together the world's most successful and inspiring people to share their stories and, most importantly, strategies for success. And now it's easier than ever to listen to Impact Theory on Amazon Music. Whether you're on the go or chilling at home, you can simply open up the Amazon Music app and search for Impact Theory with Tom Bilyeu to start listening right away. If you really want to take things to the next level, just ask Alexa. Hey Alexa, play Impact Theory with Tom Bilyeu on Amazon Music.
Now playing Impact Theory with Tom Bilyeu on Amazon Music.
And boom, you're instantly plugged into the latest and greatest conversations on mindset, health, finances, and entrepreneurship. Get inspired, get motivated, and be legendary with Impact Theory on Amazon Music. Let's do this.
It doesn't seem self-evident to me that just because, again, I'm granting you the conceit that consciousness is the fundamental thing, but it does not seem self-evident to me that even if consciousness is the fundamental thing that gives rise to this constricting rule set, as I describe it, that we call space-time, that you couldn't have a theory of everything regarding space-time. Why do you think we have failed to get a theory of everything?
In space-time.
In space-time. Knowing that it's the simulation, but going back to Grand Theft Auto, feels like even if I just said, oh, all I can tell you is cause and effect, that when this pixel goes here, it has this effect. And so now I can play everything's forwards or backwards. And you could in Grand Theft Auto. It has a set of rules and it adheres to those rules.
Right.
Period. Plain and simple. And so even though it is the headset, a computer program, assuming that a simulation acts like a computer program, space-time in this case, it adheres to rules. And so when you get a quote-unquote bug, it is what the program is programmed to do. You just didn't intend to program it that way.
Well, I in that framework, yes, I agree with you. That I think we could get a complete theory of space-time. Not a complete theory of everything, but a complete theory of space-time. So so the theory of everything for me would be, space-time is a trivial aspect of everything.
Right.
So, but absolutely, I think we can get a complete theory of space-time, and we'll see its limits. It falls apart at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. So we'll see that and we'll understand that. Yeah, so it's quite possible. I would say though, and I like your idea about the program and the rules and setting up a framework in which you can explore experiences. I'll throw in a little wrinkle. You're writing computer programs, and so Alan Turing, is sort of one of the fathers of modern computer science, and Turing machine was like the first really good theoretical framework for computer science. And the universal Turing machine that Turing described in some of his papers is sort of our notion of a universal computer. But there's a well-known limit. to what Turing machines can do. Take again all the integers, 1, 2, 3, up to infinity, also -1, -2, and so forth. And think about all the functions from the integers to the integers. For example, the square function. So, the square of 2 is 4, the square of 4 is 16, and so forth. How many functions are there? It turns out it's a bigger infinity. It's not accountable. It's a bigger infinity than the integers. But Turing proved that the set of computable functions is countable. So when you're programming, you're using only computable functions, but they're a much smaller infinity than all the possible functions. So right now in our current technology, when we build these computer simulations, we should know that we're using a probability 0 subset of all the functions that are actually available. And maybe later on we'll figure out how to do something more interesting with all these other functions. But then as we go again Cantor's hierarchy, I think that, in other words, the kinds of rules are going to be very, very hard for our heads to understand. You can write down, if you take a class in theoretical computer science, you can study non-computable functions, so that and almost every function is non-computable. Okay, as I just said, the computable functions are probability 0. The set of all functions most of those functions are not computable. But in a theoretical computer science class, you will actually spend some time actually studying, how to construct and prove that a certain function is not computable. Like the halting problem is not a computable. It's not a computable function. It doesn't. And so, but it's really hard for us, even though almost every function is not computable. Almost every function we can think of is computable. So here we are stuck with the limitations of our headset, and so thinking out of the box in this simulation idea is really going to be mind-numbing, because to really think out of the box, you're going to have to learn how to think about non-computable functions, and that is not trivial. So I just wanted to throw that out there to just open up how complicated this can be, and why the exploration
because
could
to
be.
get a theory of even just the everything of space-time, we have to get into non-computable functions?
I don't know if we will or not. That's an open question, but we should be open to that possibility.
It's very interesting.
And certainly to explore consciousness. I see no reason why we should, a priori, I would say this: if someone claimed that the computable functions were all we need, I would say the burden of proof is on you.
Talk about something I have not even considered. I don't know that I can wrap my head around that one yet.
I have a
I'll
hard
save that
time. I
for
mean,
the-
I took a class and I looked at that non-computable function, the halting problem, and you have to really, you have to be sober, you have to be well rested, and you have to think really hard. At least with my apparatus, you have to think really, really hard to even grasp it. It's not trivial.
Intense. Okay, so when we have a hypothesis that makes predictions, we need to be able to solve, we were talking about this a few minutes ago, we need to be able to solve problems, or our hypothesis needs to predict outcomes of things that we can observe but not yet explain. I can't remember if you mentioned this in your paper, but I have heard you talk about this. So dark matter, dark energy, we don't know what the hell it is, but we know that the universe would not hold together if it wasn't for that, or it wouldn't be racing apart at the way that it's racing, whatever. It wouldn't function the way that it functions now. What does your consciousness as fundamental agent tell us about dark energy?
Well, nothing specifically, right? So that's a big open question. In fact, one of the my collaborators is a student working right now on dark energy experiments. A brilliant student named Ben Nepper.
Because he thinks it will yield results tied to consciousness as fundamental?
No, I think it's just because it's a good thing to do at this stage in your career, to get that kind of experience and, actually spend time hunting with real experiments for dark matter, so you learn the ropes. I think and so he's doing that. And who knows? Our current techniques may or may not find dark matter. We just don't know. But it's no surprise from a point of view that says that space-time is not fundamental to say that there could be influences on our headset that are not explicitly represented by the headset itself. They're only seen as influences on the headset. And so one way that we're going after this in our own mathematics is we have this Markovian dynamics of these conscious agents.
Can you take a second to explain to people what Markovian dynamics are?
Yeah, Markovian dynamics is fairly simple in concept. It says that what you do next. So suppose I'm on just say a sidewalk, and there are different. I could either step one step to the right or one step to the left, and there's some probability. Maybe I choose to step to the right with probability of 2/3, and to the left probability of 1/3. And so you can see where would I go over time. But the key thing about it is that the step I'm going to take now only depends on where I am now. So where I'm going to end up next only depends on where I am now. So there's a finite memory. I don't have to know everything I've done in the past to know what's going to happen next. I only need to know where I am now. And that's the key Markov property, that you only need to really know the current state. You don't have to know the whole history to have all the information about the probabilities for what's going to happen next.
An analogy that I heard that was really helpful in understanding is if you think of it as airports, some airports have more connections to other cities than other airports. So if you're asking, let's say that there's 5 airports in question, one is isolated and one is a hub to all the rest, and then the other ones only have 1 or 2 links, whatever. Going back to your idea of if I'm on the isolated airport, there's only one option. So you don't need to know where I was before all of that. If you know I'm on the isolated one, you know I'm flying back to the only thing it's connected to, which is the other hub.
Right.
Now, when I'm at that hub that has, let's say, 5 options,
right.
Now it's just a probability curve of which one I'm going to go to. But
Exactly
once I
right.
go to another one of those airports, then it's like, okay, well, I could go, to Cincinnati, I could go to New York, I could go to LA, or I could go, let's say those are the only connections. But when I'm in Hawaii, if Hawaii forces me to route through LA, then you know where you're going to go. I was like, okay, that at least gives a simple understanding of, oh, this is a relatively simple concept that sets aside all the history. And so from a computational standpoint, that becomes very important, because when people talk about booting up a simulation of the universe, you very quickly to track every element that could possibly interact with if everything could interact with everything, it becomes impossible. And you would have to have a computer the size of the universe itself in order to track like a 1-for-1 atom, basically. But I think I'm understanding this right, that Markovian dynamics eliminates a lot of that computational need, because I don't have to, there is a small set of things. And once I know the probability distribution, over time, it completely stabilizes. And so when I know if I'm at airport C, I know the exact probability of where they're going to go next.
That's right. So the Markovian dynamics help simplify things by demanding only a finite memory instead of an infinite memory of the past history of what you've been doing. But you can make the memory as big as you want. So it's really not too much of a limitation either. So it's a nice formalism.
So why do we care about it?
Well, most of us don't have to deal with infinity anyway in terms of past history, so we can just use finite histories, and that's quite good. And another reason to be interested in Markov dynamics is we talked about computable functions. Well, Markovian kernels are computationally universal, so anything that can be computed with a neural net or with a universal Turing machine can be computed with Markovian kernels. So they give a nice network kind of modeling for dynamics, but they also give us universal computational abilities. And they're not limited to computable functions, because the sets on which the probabilities are defined need not be computable sets. So they actually give us a window toward going beyond computation. I'm not there right now, but that window is there in the future if we need to go there. Hopefully that will go there. But so our current model is a Markovian model of conscious agents. And then what we have to do is we can then show that space-time is just a projection of this dynamics. And so there's a lot of states.
Really fast before you move on. So just re-anchoring people that these conscious agents, the states that they can be in are coffee, elation,
Right.
desire, headache. So when we're talking Markovian dynamics, we're talking about moving from one of those qualia states to another, a human headache versus a dolphin headache, et cetera, et cetera.
Right.
So help me understand why that's important, that I can, like if I'm in the state of blissed out coffee taste, that I have a certain probability of going somewhere else. That feels counterintuitive. It feels like my wants and desires are really what's going to drive the next state, not the state that I'm currently in.
That's right. So now we're just talking about the consciousness, not about space-time for this question,
Yes.
right? So there, when we write down a Markovian kernel and say, okay, whatever your conscious experiences are now, this Markovian kernel describes what your next conscious experiences will be probabilistically, and also how you're influencing the conscious experience of others. So now we can ask the kind of question you're asking. So
That's happening outside the headset?
this is all outside the headset, right? This is all out. This is
So the probability of what I do next is determined outside the headset by Markovian dynamics.
that's why we're going to get to this dark energy and dark matter stuff.
You are breaking my brain right now.
That's why I brought this up, is because your question was about dark energy and dark matter. So what we have to get at that from this point of view, what we're going to say is, look, most of the states of this dynamics are states that are not represented in space-time. They're dark. So there are these influences that you're not going to see. When you count up all the matter and all the energy that you can see inside space-time, you're going to be missing all the stuff that didn't project into space-time. So in fact, probably the dark energy and dark matter is much more than we've discovered so far. So that's why it's important. But
So, okay, hold on. This all really does start to feel weird when I remind myself that this is about qualia,
right.
the sense of it being like something. And so I'm going to make something up. Dark energy is the energy created. This is why I don't understand how it could be energy, but dark energy is the energy of a qualia that I will never be able to experience. So it's something like an alien drinking blood wine, making that up, but it has to be qualia. So it's got to be something to be like that thing. Is that
Well,
right?
it's even more complicated than that. It's not just one qualia. It's probably who knows how many countless infinities
But
of
it would be
qualias.
things like that, right?
Exactly right. That are interacting and affecting the dynamics that we perceive inside of our space-time headset. But notice that among the qualia are, for example, the qualia that you are about 4 feet from me. So your position. There's a quality. I mean, it's very, very different to experience you 4 feet from me than 4 inches from me.
Facts.
Those are very, very. So depth and space is qualia, and in fact, our qualia there sort of compresses. If I look at like a distant mountain, and the moon rising over that mountain, the moon looks a little further than the mountain, but not much, right? Yeah, the moon's a little further. But if you were to, that mountain might be, 20 miles from me. The moon is 250,000 miles from me. So that means you have no idea that it's like orders of magnitude further away. So our qualia space of depth is quite compressed compared to what we might call the measured world. So like when you actually, and you see that in your, like a Grand Theft Auto, when you're actually looking around, you only see the roads around you in a little bit. But the Grand Theft Auto world, you might be able to drive thousands of miles in a really complicated simulation, you don't see thousands of miles in any one time. You only see a little bit that your headset allows you to see. But because you use that same headset and you're not stuck in that world, there's actually a supercomputer that has a much bigger world than your headset, right? Than what you see right now in your headset. But it's rendering a little bit in your headset right now. So that's why the mountain and the moon look about the same, because they're headset. We can now, of course, when we go to the moon on a rocket, now it's like going through Grand Theft Auto with your headset on and going places that you couldn't see because they were too far away in your current headset view, but you can get there eventually. And so that also is pointing to a world outside of your headset. Your headset is just what little bit of that world that you're rendering at any one time. Now, dark energy and dark matter.
You're not really getting outside of your headset to go to Mars. You're getting outside of what you rendered previously.
Well, so at any moment, you're only seeing in your headset, right?
But if I go to Mars, I'm still seeing in my headset.
Yeah, and in Grand Theft Auto, for example, there might be a Porsche that's 1,000 miles away, and you're gonna have to drive like 3 hours in the game to get there. So you're not gonna see it. So it's in the simulation outside of your headset right now. To get it in your headset, you're gonna have to do all this work to get it inside your headset. But it already existed in the software in the computer prior to that. You just don't see it in your headset.
Understood.
So all the stuff inside space-time, the galaxies that we see that are far away from us and so forth, that's not dark matter, dark energy. That's more like the headset stuff that you see in Grand Theft Auto if you go far enough within the game. But then there's this deeper notion that there are some states in the computer that you'll never see in Grand Theft Auto, but they could, subtly influence what you are seeing in Grand Theft Auto.
Doesn't your thesis necessarily, no, you're not going to say yes to this, but I'm going to finish. Doesn't your thesis necessarily mean that is some element of I like to think of it as a blob that is consciousness cycling through, why would it be in the same simulation? Cycling through different qualia, but then I don't understand why it would be in the same simulation if it's going to be something I could never possibly interact with.
Right. I mean, almost everything that the real consciousness is doing is not in our headset. We have this. What we're perceiving is probability zero of what's going on. It's basically, if you ask, of all the things that are being experienced in consciousness, what percent of it do we experience? 0%. 0%.
Yes, understood. But I am in a way experiencing dark energy because it is the thing that makes the universe the way that it is now. So I'm just trying to understand. So the thing that I'm sort of debating in my own head is, okay, when I grant you that consciousness is fundamental, then there's all this internal logic to the space-time continuum that I know and love.
Right.
But I don't know that it's the only way for me to apply the sort of same rationale that you use of whether it's Markovian dynamics. Gödel's incompleteness theorem is probably the more important because that's the one that really helps me understand AI and what AI is doing. So I'm wondering, okay, if I for a second say you have touched on something that's really important, which is that space-time is the simulation, but I don't need to draw the conclusion that consciousness is the fundamental thing. Agreed. That just becomes a debate about whether consciousness can emerge or not. It could be that and this feels more right to me when I try to imagine it, but I fully admit what I'm about to say simply pushes God farther down. It kicks the can. Okay. So what feels intuitive to me, because it's what I'm doing, is that I exist in somebody else's simulation that exists in the real world. And that person, they still need God or something. I have not in any way, shape, or form explained that. I've kicked the can. But then all the sort of, there's a set of rules. They seem like they're a little too perfect. They're a little too finely tuned. You've got the Fermi paradox, which I'll probably ask you about later. Sure. Like all these things are like, this is a little sus. The way that this whole space-time is trying to hang together just doesn't really quite complete the circle, including so much of the energy that makes the universe work is this dark stuff. Don't worry about that. Feels like a 13-year-old programmer hand waving it away, telling the teacher like, I just needed something in order to, make all of this work. And when I do that, everything also falls into place. Where I'm like, oh, wow. Okay. So I get how they're rendering all this in real time using the same principles that I'm now seeing AI use, pulling things out of the possibility space. Because as somebody developing a video game, I will just tell you, the hardest thing is creating the art assets. So they need something that can render this stuff on the fly and creating the art assets that look good, but are also optimized for the rendering engine, because the rendering engine just gobbles resources. Right. So it's like, when I take that view, and instead of going, there's this magical thing called consciousness, I'm like, I'm still dealing with God. There's a God somewhere doing something, whatever. There's a thing I don't understand. But space-time being born of a 13-year-old just trying to, like, you could literally go to the Unreal Engine store and be like, give me Einstein's physics.
Right.
And you plunk them in and it would work. He wouldn't even have to know how to program it.
Right.
He just took it, whatever, give me what they understood in 2023 and let's drop it in.
Right.
We'll see what happens. Like, that still works.
Exactly.
So
I agree.
What is it that gives you the confidence that the thing that is giving birth to all of this is consciousness itself?
Oh, I'm not confident at all. So everything
is it your leading theory?
It's just my leading theory.
Why is it your leading theory?
First, I would agree with you that we could just say that there are some kind of dynamical entities outside of space-time, and be agnostic about the nature of those entities. Just write down their dynamics and then show how it projects into space-time, and we could be good. Absolutely. The reason I'm going after consciousness is two things. Very personal first. I mean, we all have headaches and we have conscious experiences. And so we want to understand what consciousness is, right? And the standard view right now among my colleagues in the neurosciences is that consciousness is something that's created by brain activity or embodied brains. Or perhaps, if we're lucky, AIs and so forth. But physics is fundamental, physical stuff is fundamental, and consciousness is a latecomer. If space-time is doomed, if space-time is not fundamental, that whole story of consciousness is out the window.
Does physicality go out the window? Let me see if I can answer my own question using your words to see if I understand this. Is physicality out the window if space-time is doomed? You would say yes, because local realism is proven that it isn't. There is no local realism, that all of this is fake. Everything you see and experience, it's all just quote unquote rendered in real time as you engage with it. Therefore, at least in what we experience, because local realism isn't true, physicality cannot be true.
That's right. To put it very simply, I don't have neurons right now. If you looked inside my skull, you would see neurons. You would render them. But there are no neurons. Right? So neurons do not exist when they're not perceived. So neurons couldn't create consciousness because they're not even there to do it. Mm-hmm. And nor could particles. Particles don't exist when they're not perceived.
Here's where limited minds like mine get tripped up. Because your analogy is so profound and feels so right, and for this to be a simulation, I say to myself, something has to be running the simulation. And I can't get myself outside of that. Something somewhere is going to be physical.
That's a hard one. For me, too. By the way, I have all the same knee-jerk emotional reactions that everybody else has to this stuff, even stronger. So maybe that's why it's good for someone like me to be doing this, because, my emotions don't believe any of this. They don't believe it at all. It's literally only the mathematics pushing me, kicking and screaming at each step. You have to go with the mathematics and what the theories are saying. But I don't find it that intuitive. Maybe I will at some point, but I don't find it that intuitive. So yeah, you could say, we don't need to talk about consciousness. There's just some dynamical entities outside of space-time.
Why can't consciousness be a part of the simulation?
It may, for all I know, it may be. So maybe this thing that I called awareness, where this prior to any particular conscious experiences, now there I'm completely in over my head. I have no idea what to say about that thing, right? I literally have nothing intelligent to say.
What if awareness is just the qualia of being rendered, of your process being run by the central computer?
That's as good an idea as I've ever had, but I don't feel very confident in this area at all. I mean, the closest we can personally get is the kind of thing I suggested. Go into a quiet room, turn off the light, let go of thought, which is not easy. Let go of everything and try to just be aware of awareness. Be aware of being aware, and try to sit there with that. And what you find is it's a profound experience. The more you just sit there, being aware of awareness without thinking about, you're not. See, the whole point about not thinking is thinking. You're back into this small computational realm. You're back into this really tiny, out of all the infinities. You're back in this little tiny infinity. So letting go. So this is not.
Well, we know the headset is computation, though, right?
Well, we don't know for sure. Our current models are, but we haven't
Doesn't
proven
local realism not being real mean that it has to be computational?
No, it doesn't entail. I mean, so it doesn't entail that at all. No.
Huh. Now I'm broken again. I don't know how to make sense of that.
Right. So
How can anything? This is interesting. Here's my base where I realize I don't know how to escape this. I feel like for qualia to exist, it must be processed. I will even grant that the processing is simply the Markovian dynamics of moving from one thing to another, the switching of states. Fine. But it is moving from one state to another, which I will call that processing.
right. Yeah, it's just not a physical process. It's and it doesn't have to be a computational process even. It could be functions that are not computational.
Yeah,
I
try not to kill the audience with the things that I just can't wrap my head
Well,
around.
it hurts me too. I mean, I'm telling you these things, but not because it's easy for me. My head hurts too thinking about these.
Do you have an
things.
example of something that's non-computational? I think you gave one earlier, but I forget.
Well, so the standard story that if you take a computer science class and study the theory of computation, they'll tell you about something called the halting problems. So this is like one of the big problems and Turing, I believe, posed it and showed that it was not computational. The question is this: if a Turing machine is like a universal Turing machine is like a universal computer. You can give it a program. Turing thought about putting a tape with some punches on it, essentially. So you have this tape reader, and the Turing machine would look at one square on the tape and read that symbol, and then it would change state, and then move left to right and write a symbol. And that's all the universal Turing machine could do. And so the question that Turing asked was, suppose we asked the question, will the Turing machine stop after a finite number of moves? Will it halt? On arbitrary sets of these tapes that you're giving it, programs. That's called the halting problem. The question is there a Turing machine that can decide, so is there an algorithm that can decide whether this Turing machine will halt or not for any particular given input?
So can you tell the Turing machine to stop? Is that the...
Well, no. So I should say one more thing about Turing machines. So a Turing machine is going back and forth and changing its state. And when it's done, when it actually is like computed the square of a number or whatever it is that it's doing, it halts. It goes into what's called a halt state. And so that when it goes into a halt state, that means it's done. It did the computation. So, but there are some computations that go on arbitrarily long.
I don't understand why.
You never come to the end. You never come to the end of it.
There's some sort of recursive loop in it.
Yeah, that's
by
right.
its nature.
In fact, probably most. So the question is.
So when you say non-computational, you mean something that ends up in that loop?
Yeah, where the Turing machine never halts. You give it an input.
It never thinks it's done.
And it never thinks it's done.
Got it.
So the halting problem
most
is.
things are like that.
Yeah, I would guess that. Yeah, most tapes are probably. You wouldn't halt, would be my guess, but that's not an important point here. I think that's the case, but it's not a central point. The fact is that many won't halt, and so the question that Turing raised was something like this: so is there a Turing machine that can tell you, if it says given this Turing machine and all these inputs, whether this Turing machine which one of these inputs will it halt? Okay. And it turns out that there's no Turing machine that can do that. So it's not a
There's
computable
no
function.
Turing machine that will know which one is going to halt.
That there's no Turing machine that can tell you that whether this other Turing machine will halt or not on all these inputs.
Interesting. So it can never understand it without running the calculation itself?
Well, and the Turing machine itself would never halt. The one that was trying to do this would never halt. So it's called the halting problem, and it's so when you take a computer science class, you'll get a much better explanation than I've just given you. But basically, you'll see that there's no algorithm that will tell you whether a particular Turing machine will halt or not on any possible inputs.
So when somebody says it's Turing complete, does it mean that it halts appropriately, or is that something else entirely?
That's something else entirely.
Got it. Okay, that's crazy. Persistence.
Yes.
So this is, I think a key part of my thesis, which is persistence is the hard problem for AI right now. And when I look at the thing that holds AI back from being something that people can implement into their workflows today, it's because it can give you really amazing stuff, but it cannot give you really amazing stuff over and over from different angles and different setups. People are working on it, and by the time this comes out, I'm sure it'll be even better. And a year from now, it'll be a solved problem. But that feels like part of the rule set that you need inside of the headset is to create this sense of persistence. So I wonder if, again, going back to the idea of the headset becomes necessary because you have to create persistence in order for the qualia to be explored. You have to have that. Do you agree with that sense of persistence being a necessary tool of consciousness to explore qualia?
Well, first, I'll just say I think a concrete example of the persistence is like I look up at the moon, and then I look away, and I say, "Is the moon still there?" And you look up and you say, "Oh yeah, the moon is still there." And then you look away, and I look, and so every time I look back, I still see the moon where I expected to see it. That's what we mean by persistence here. And I don't think that we need to have that kind of persistence to have a headset. I think we do. We have that. But for example, there's E. coli bacteria. The way I understand what I've read is that it swims along, and there's some amino acid or something that it's eating, and as long as there's a good gradient of that thing, it keeps going in the direction it's going and eating the stuff. But if things start going south and it's not getting the amino acid or whatever it is it's eating, it's flagellum that it's using to move forward. It turns it in the other direction. Which makes it's like a random turn. So it just rotates the other way, and that gives it like a random so it's like a random orientation generator. It orients as a completely new generation, new direction, and then it starts going. And if it's good, then it goes. And so that's its search mechanism. It's a very stupid, but it works for the E. coli. Now, does E. coli necessarily have persistence?
Yes.
I don't know.
Yeah, 100%.
Okay.
It must.
Okay.
So right before we started rolling, I had the very good fortune of introducing you to another one of my favorite people,
Right.
Eric Weinstein. And one of the things that he said to you was that you said, I don't have neurons. And he was like, what? And he had earlier made a statement that you couldn't, because you had never met him before, there's no way for you to render him upon entrance because he remained consistent to himself, to me. And that's what I mean by persistence. So if I look at E. coli, let's say I'm the first person to discover it, it will look a certain way. If somebody else, without knowing I discovered it, also discovers it, it will look the same way. If a person...
Well, I agree with you on that. My question was different. From E. coli's perspective, I was thinking through the headset of E. coli. So E. coli has its own headset.
Mm-hmm.
And I'm just wondering, for E. coli, see, it may not need to have this persistence notion because all it needs to know, I'm happy, I'm eating.
Wow. So this
and then
shows the importance of defining terms.
Right.
So what I mean by persistence is that you will look the same. So when you look up at the moon and then look away and it gets trash binned in your headset, and then you ask me, is it still there? And I look up and I'm like, yeah, it's still there. Every time I look at the moon, it's going to be the same. Every time you look at the moon, it's going to be the same. And if somebody were to take a photo of that, we would both recognize that photo as being accurate.
No, I completely
Now,
agree with all that.
If I'm building out a simulation, I don't go, here is marker for moon, represent it differently to you, but consistently, represent it differently for me, but consistently. I go, make the moon persistent. The moon will always look like this. And that way, no matter who discovers it, they would describe it the same. They would see it the same. Like, rather than me have to be like, oh, you're calling it red, and I have to remember that red is different for this guy. And so it's like, how do you know that red is the same? If this is all simulation, it's obviously the same, because otherwise you would have to like program the shit like 1,000 different ways. Now, you may experience like additional layer of sentiment about a thing that makes the qualia different, and this sort of gets into your hierarchies of infinity, that fine. But going back to neurons, if I smash somebody's head 1,000,000 years ago, maybe that's too far because the brain's changed, 100,000 years ago, neurons would look the same even though I don't know what they are. I'm just like, meh, that's when you smash a head, this is what you see. If I smash that same head today, I'm going to see the same thing. Right. Because even if this is all a simulation, there is a level of persistence.
And I completely agree with you on that. I was just raising the question, could we come up with a game that was so simple, that was so trivial, that in some sense persistence was irrelevant? I mean, you either you're told bad or good. That's all you're told, bad or good, and you do something random. That's what I'm saying, the E. coli.
Yeah, you're talking now about behavior. Okay, which
right.
So if we're in agreement on persistence,
yeah, I agree on the persistence stuff.
Just to say it another way, the simulation is a set of rules, descriptions, assets, like art assets for just an easy way to explain it. And so there's going to be uniformity across everything that uses a headset. They're all going to be the same. So I don't have to like create all these individual things.
I agree. Yeah.
Then you have a very separate notion, which is the behaviors. We were talking about this earlier. This still really, I don't know how to understand it. In your paper, and this is probably a good time to now get into the paper. Okay. So the paper felt like, as a layperson who's interacted with you in an interview format, but never having, I had your book, but again, that was more inviting people into popular science, whereas the paper was like deep mathematics. Mm-hmm. Felt like a step forward in your guys' certainty of at least how to explain what you think. Right. But one of the ideas in the paper is this action potential. I can't remember if that's how you described it. But so I want to go back to this idea of and this is where I sort of started thinking this makes more sense to me as a 13-year-old programming a set of rules than it does consciousness giving birth to a set of limitations in order to experience qualia, because then every computation has to be about qualia, which I may have said earlier, but I want to say something that I think you actually state in the paper. Okay. If this really is consciousness is the fundamental layer, and all consciousness is trying to do is run the Gödel's incompleteness theorem against all of the qualia that it could experience, and that the headset and our biological experience, which is really just the thing inside the headset, are simply constraints for it to express qualia. All math is the representation of the different elements of qualia. So whether that's probability of given behavior, likelihood of moving from one thing to another, one state to another, that's all math is here to compute. And in the paper, you touch on, I'm calling action potential, but that could be my poor memory. Yeah. I feel like I have free will. I think it's an illusion, but I feel like I have free will. But all of this qualia, if it is true that that's what's really happening, and this is just consciousness running through all the different qualia, it doesn't feel like that to me. So there's some element of the simulation that makes it feel like I'm living a life, and that the qualia is born out of me living a life, not born out of, I don't live a life so that I can experience qualia. But your hypothesis, I think, mandates that my life is the consequence of cycling through qualia and not the other way around. And it's the Markovian dynamics of the likelihood of me going from this state to that state that dictates, that forces my life. Is that accurate?
Well, not quite. So there's this complicated dynamics of consciousness going on, and the coin of the realm are experiences, and that's the hypothesis. So that's, experiences are being shared and triggered. So think like the Twitterverse, right? But what you're tweeting are experiences, and what you're receiving are experiences.
So the consciousness must break into a just metric shit ton of separate entities for this to work.
That's right. So we're gonna have this. It's like the Twitterverse is huge, millions of users and so forth. If you look at my Twitter page, right, there's only a small number of people following me and a small number that I'm following. So I'm getting a tiny picture of Twitter. There's a big social network, a lot going on. If you look at the projection onto Hoffman's little thing, it's just a small little, and if that's all you saw, you wouldn't get a feel for everything that's going on in Twitterverse, because I have very specific interests. I mean, you'd think that everybody likes consciousness and mathematics and is a geek, and they're not. So you'd get the wrong picture about what really is the Twitterverse. And so I would think that all the headsets are just projections, like taking the Twitterverse onto one person's Twitter account. They're projections onto a consistent, as you point out, to keep persistence. You might want to have a whole group of them that see the same thing and can both agree that all agree that there's a red Porsche or something like that in the game. So you could have a bunch of them that have similar projections of the one bigger conscious dynamics. Maybe I should just stop there and see if that's addressed your question. Or
it has not yet. So
okay,
what I'm trying to figure out is about action. So I feel like I'm living my life.
Oh, am I actually making a choice?
Yeah, like what do you think, does my life arise out of me taking action and having wants and desires? In fact, that's probably the base way. I would predict, based on how it feels, that the 13-year-old, because I probably make that, my things fit better for me if I just assume that you've got a 13-year-old who pulled Einsteinian physics off the shelf to put into the program, and they're just running it based on a set of rules, but it doesn't really matter. But we get to, here's how it feels, that I was given a set of wants and desires. And here's where evolution comes in. So I want to survive long enough to have kids that have kids. And then everything in my life is just an echo of that. It's like a hilariously limited amount of rules that you have to give to me, sort of based around how I stay alive, the desire to stay alive, what I want to quench hunger, thirst, sexual desire, so on and so forth. And then you just let me go. And when you think of like a human as a character in a video game, has certain stats. So you marry those wants and desires with those stats, and then you just let them go, and you see who they bump into, and you had childhood trauma, and so that's gonna change your stats. But it's like you just watch how all that plays out, and so you get, and I think this is why people are really going to struggle with this. Isn't an emergent phenomenon, because when I think about building the game, I am just beating it into the head of the team. We want the community to create emergent phenomena that rises out of the nature of the rule set and the technologies.
Right.
So I'm not trying to create the emergent phenomena and then hope that the technology is born of that, which is basically what you're pitching, I think. And so I can get behind it when I think, this is just Gödel's incompleteness theorem. So there's an infinite number of things to cycle through. And as long as I grant you that consciousness, for whatever reason, has a desire to cycle through all of that, then everything does make sense. It plugs in and it works. But then I'm like, wait, the only part of that then I don't know how to conceptualize, because it could just be that I'm trapped in my headset and I'm not thinking about it right. But what I don't know how to conceptualize is that I am living a life. And so to your point that whatever exists outside of the headset has got to explain what's in the headset. And I am living my life. I'm not just cycling from random qualia to qualia to qualia. The qualia that I experience seem mapped so perfectly to the actions that I take, which are clearly influenced by how I feel. That I get.
Right.
But it manifests as I'm feeling tired, therefore I go to bed. Right. Therefore, I have the experience of the softness of the sheets versus the consciousness saying to itself, I would like to cycle through the softness of sheets now. So either this is the consciousness has like an agenda and it knows how to create the simulation in a way that's going to yield the best outcome. And so it like sat there like, oh, what would be the best way? Like how it creates humans in the way that it creates humans. It creates life in the way that it creates life. It creates day-night cycle, which already creates like so many limitations on us and shapes our fundamental evolution and all of that. I'm just like, do you really believe that's consciousness that set all that in motion? Or is that emergent phenomena out of a simpler thing that consciousness, like if consciousness just gave birth to the laws of physics, then I'd be like, word, this all makes sense. Consciousness just becomes God. Fair enough. But if consciousness in your explanation is anything other than God, I think I'm confused.
So great question on the free will and then the nature of the origin of this headset. And is it just all pre-programmed or is there room for exploration?
That's not quite what I'm saying. What I'm saying is I know it's pre-programmed because the headset, which you have agreed with, has a set of rules.
Right. Well, yeah, that it does have a set of probabilistic rules.
Yes, but to get there, you need rules. You
Absolutely.
need rules of
Right.
probability. You need at a minimum math.
Absolutely.
Right? So something somewhere, either math is fundamental or consciousness created math as a way to create a set of rules in order to experience qualia, which that is hard to wrap your head around. But
Right. So
is that assumption correct? That assertion, I think, is a better way. Is that assertion correct?
I'm not sure. These are deep waters now. So that's why I'm myself now having some difficult trouble. So I would say the free will question first. When I look at our mathematics, I could interpret the Markovian kernel for a given agent as representing the free will choice of that agent. I could interpret it that way. But if I do that, I look at all the others and it's being affected by all the other conscious agents. And you can
So my probability space is being impacted by the other conscious agents.
that's right. But you could say this is just my qualia are being but my free will is not. But here's the trick is that groups of conscious agents that satisfy certain conditions are also a conscious agent. So that means if I think about all the individual smaller agents as having free will, and then this new agent also has, if I think about having free will, I would need to have a new notion of free will that's really quite an interesting one. It's going to be a scale, in some sense, a scale-free notion of free will that can go for
What is a scale-free
that
notion?
it'd be true at all scales. No matter how many conscious agents I put together to make a big conscious agent, I would still be able to talk about this agent has free will, but all of the constituents also have their own free will. My guess is that might be able to be made to work. So that the question is, if I say, is it only the one big consciousness that has free will and we're all puppets, or do all the little consciousnesses have free will? The answer might be both. But you're going to have to, but there'd be this new mathematics that shows in some sense that the free will of the one is made of all the genuine free will choices of the individuals. And so it's not like a autocratic God saying you must do this. It's rather a God exploring all of its own possibilities, so to speak, freely through all of the components which are also freely interacting. But their free interactions are all part of the one freedom of the one. In other words, I think that there could be a mathematically consistent notion of free will that doesn't say either or, but both and. So we get this scale-free notion. I haven't written it down yet, but that's why I'm saying that these are deep waters, and this is where we're going to have to answer your question, we're going to have to go after some deep mathematical theories of what we mean by free will. My guess is that it's possible, but we'll have to see. That we could have genuine free will at the smaller agent level, and that's not incompatible with free will at higher levels, and even the free will of whatever the super. I mean, I can't even describe the one agent. It transcends any mathematical description. So we could never actually get this mathematical model in the final limit that I'm describing, but could we get it in smaller infinities that we can deal with and show that it works there? We can't get to Aleph infinity, but we can go maybe in smaller infinities and see if it works there and get some hint. Ultimately, I mean, the reason why I said I'm in deep waters is because I know that ultimately I can't answer you. Ultimately, I can't get to a final description of the one agent. I mean, it literally, our mathematics says it transcends any description. So I have to halt and say, I can't tell you, I can only tell you about projections of that one. And from the projections, the mathematics points to the one, but our analytical tools fail us. We can't actually go there.
Can you walk me through how the how the projections point to the one? And the one being like the one, God, consciousness, it's like a thing. Yes?
Well, again, that's a good question, because I mean, I'm not saying that the data we have uniquely determine this theory, right? Absolutely not. So I would say they point me as a scientific theorist toward this hypothesis. Here I am with conscious experiences, interacting with others that I think have conscious experiences. My physicalist framework can't explain them at all. And so I'm proposing that there are these conscious experiences that give rise to space-time as an interface. And when I write down the most simple mathematical model that I can do for that, all of a sudden that mathematics, I wasn't intending it, but the mathematics points to a single major consciousness that I can never describe. So that's the sense in which I say it was sort of pointed to that. And I would guess that other conscious agents with either interfaces that are not even like our space-time interface, but have mathematical skills, and are coming up against the limits of their own interface and starting to realize, oh, I thought this was real, but this is just the interface, might, under the hypothesis that consciousness is fundamental, might run into the same thing and then get pointed by their own mathematics to a universal consciousness. But again, these are deep waters, and I'm not secure here at all. But I would say that the free will. I mean, I've have good discussions like with Annaka Harris and so forth about free will, and free will is standardly understood. Probably not, but free will in this new sense in which I'm saying that there could be a scale-free notion and a new mathematical model of free will that's scale-free, quite possibly there. And to your point about it's not dictated. There's exploration, real exploration going on. I would again agree that there's real, to the extent that I'm talking about all these little agents having their genuine free will. There's genuine, real exploration going on, even though it's not contradiction to say as well that the one has the free will. See, in other words, in some cases, when we think about things, we think it has to be this or that, but when we look at it more closely, we realize that there's a deeper way of thinking about it in which both can be true, and we hadn't thought about it that way.
Okay, so if those are deep waters, I'm going to drag you to the bottom of the Marianas Trench on this one. Does consciousness have a form?
I would say awareness has no form, but assumes all sorts of conscious forms.
I'm trying to sneak up on an idea here, and I'm not sure the right way to ask this, but it's like when you talk about the headset is a simulation born of consciousness itself. It is emergent from consciousness.
Right.
Because the headset is so specific and acts in a very specific way. And as I think about AI and the way it pulls images forth out of the possibility space, it does it in a certain way. And you can create different kinds of AI that do it in slightly different ways, and they yield different outcomes. And so for the headset that we all experience to be the way that it is, it requires consciousness to be a certain way. And so what I'm trying to get to is, when there is no physicality, how does it ever become a certain way? Because the way that consciousness could act would have to pull from a probability space. But if I'm right about that, then math comes before consciousness. And if I'm wrong about that, I don't understand what sets consciousness moving in a specific direction.
Well, I think that there are countless ways that consciousness can create headsets, and it does them all. And so one thing that we have to do to answer your question, and I'm very interested to do this, but it's going to be hard work, is to actually use the Markovian framework of conscious agents and actually write down a dynamical system of conscious agents that constructs our space-time framework, our space-time headset. Right. So that's
how would you, because if there's an infinite number of potential headsets, how would you begin to narrow it down to the headset we actually have?
So what we're going to have to do is think about a really large dynamical system of conscious agents, which will never be close to the big one that we really need to get to. So we'll always be starting with a system that's big for us, but trivial compared to the one. But that's all we can do as scientists. So I'll have to start with something that's big for me, and then show that it has its own dynamics, which is quite complicated. Now I'm going to make a smaller headset projection of it using part of the agents that are available in it to create that. So there'll be maybe I'll have like 1 trillion agents interacting, but I arrange for dynamics of, say, 1 billion of them to be creating a particular space-time headset. And then what I would do, so I know, because Markovian kernels are computationally universal, I can do that. I can use the whole language of conscious agent dynamics to create a projection into like a space-time headset. I know that they're computationally universal, so I can do that. Now the question is, once I've got that dynamical system and I have some of the agents creating this headset, what happens when I turn that headset and have it look at the whole agent system, and in particular, the part of the system that creates that headset? So I'm taking a bunch of agents and their dynamics is creating a space-time interface, but now I use the interface to look back at the only thing that's available, which are agents. That's all that's available to look at. But I want to look at the agents that were particularly interested, that were involved in the creation of the interface. What will that set of agents look like? They'll look like neurons and brains. In other words,
why would they need to look like neurons and brains?
Well, for us, for that's what, in other words, I'm saying.
I thought they didn't map like that.
Remember, neurons are just artifacts of the interface. They're symbols in the interface.
Yeah, but pulling from our earlier interviews, and so we definitely haven't talked about it this time, and maybe your thinking has changed, or maybe I misunderstood your thinking previously, but it was my understanding, I think I was asking you specifically about the moon. And I was like, but there's gravitational concerns. It can't not represent something underlying. And you said, Tom, you're making a mistake. This is all a simulation. Gravity is a simulation. The moon is a simulation. You don't need the moon there to simulate gravity, to move tides or whatever. They can just be programmed rules, and that's just how it happens. And I was like, whoa. So why then would the things that create consciousness and thinking look like neurons in my brain? It doesn't seem like they would need to map like that.
Well, right. So the moon doesn't need to exist, but there's going to be a systematic relationship between the symbols in your headset and whatever the software is. Right. There's going to be a systematic relationship between them.
So that tells me, God, I'm really trying to guess how you're going to say this. That tells me, I know this is wrong because I know you don't believe in this, but that tells me that there is physicality to consciousness, that wherever it is, that there is some parallel representation, but that for there to be a physical, God, help. I can keep making guesses, but I know that I'm hitting dead ends of things that you disagree with. So what am I getting wrong right now?
Yeah, I'm not sure yet. So,
So I'll keep guessing then.
Okay.
What I'm trying to figure out is for there to be a corollary of producing consciousness to actually look like neurons, or that
It's not,
I'm hung up on the word look like.
okay.
Will it actually look like neurons?
Well, so consciousness won't look like neurons, but one could build. I'll put it this way: you could build an interesting interface, such that when the interface looks back at the whole conscious agent network that created it, it would see that as if it were neurons and brains in projection. I mean, so I'm not
Because
saying
that's all projection.
it's all projection. So I'm not saying it's necessary, but I'm saying I could easily see making that happen.
So when we in the headset Smash a Brain look at neurons, we are seeing the representation of what is going on at a deeper level. Is it
Outside of space-time.
outside of space-time or a deeper level of the simulation?
Outside of space-time, which is a deeper level of the simulation, right? It's I hope we're using language the same way.
Probably not, but you're much more comfortable with that that things are not physical even outside of space-time. I see it as it's a maybe different set of rules or something, but that it's still physical. But I accept that.
Well, there
as
are
my
rules.
limitation.
So there are going to be rules. Maybe physical, I mean, made out of matter inside space and time. That's what I mean by physical. Something that's made out of particles in space and time. And
Yeah.
by hypothesis, the conscious agents are not inside space and time at all, so they're not physical in that sense. They are rule governed, and I can say that they exist, even if I don't perceive them. I could say that they exist, whereas stuff in the headset is only there when I render it. So maybe we're not disagreeing. And I'm not saying it's necessary that when you use your headset to look at the agents that create the headset that you will necessarily see neurons. I'm saying that we could easily set up a situation, or with some effort, we could set up a situation in which that was the case. In other cases, you might see only a single neuron, for example, if you're a very simple thing, or some other structure. Depends on the nature of your interface. But for an interface like ours, so another way to put it is, here's what I think neurons are. Neurons are our interface looking at the conscious agents that are constructing our interface. That's what neurons are. They're the interface symbols, headset symbols, that our headset gets when it looks at the conscious agents that are constructing the headset. That's so.
Okay, so I asked a variant of this question earlier, but I don't think we ever got to the answer. Okay. So as we make all these breakthroughs, would you stay inside the headset if you could? There were two paths before you. Path number one is you completely exit the headset, and inside the game world, the simulation, your avatar falls over and basically appears dead. But you are now like out chilling with the consciousness, or you return to the consciousness as maybe you become aware of your oneness with the consciousness. That feels like the right way to sum up the way you see it. Yes?
Yeah, I think that idea is can't be dismissed out of hand. I think it's a very interesting idea, and I don't have a better one right now. So yes, it feels to me like I'm not my body. My body is just an avatar. If you're in virtual reality, and you see your
do feel that.
No, I would. Well, I think that I'll say that. I'm very much attached to my body, and if something hurt my body, I would be panicked and so forth. So I don't feel like I'm not my body, absolutely. But when I'm thinking intellectually and coolly about things, if something actually happens to me, if I'm in a car wreck, it's a different story. But just thinking intellectually about it, and maybe if I meditated more, I would actually feel that way. But I don't. Just intellectually, it seems, I don't know. I'll just leave it at that. Yeah.
So I asked that part of it because what I'm really trying to get to is if you could return to oneness with consciousness or stay in the matrix, but be like Neo, where now you know how to bend
Right.
it to your will.
Would I?
Which would you prefer?
Well, my guess is at death, we take off the headset and maybe we lose a lot of stuff that was in the headset, but we don't, but we're still aware. We're just not tacked into the headset anymore. That's my best guess. And so there I am completely open to being wrong, deeply wrong. But there are near-death experiences that may or may not point to that kind of thing that people have. I'm going to be being part of I'm part of a film where they discuss near-death experiences, and so I talk about that possibility in the film from this point of view, and so if I were a physicalist, it's real clear there. If the brain is somehow creating consciousness, then when the brain is dead, there's no consciousness. This other view that says consciousness creates space-time and brains as just headsets has open to it that my consciousness, where I put my in quotes, the consciousness that's looking through this avatar does not perish when the avatar perishes. That's certainly open to this point of view. That's not what motivated the point of view, but it certainly is open to it. So intellectually, I'm open to that point of view. Emotionally, I fear death. So even though intellectually it seems quite reasonable, I have the Darwinian fear of death that's wired into me, and that's part of the game.
So there's two buttons before you. One, rejoin the consciousness. And let's say for now, that really is what happens. So you would maintain a sense of awareness, but all of your sense of self is gone forever. Or you stay in the matrix, knowing that it's fake, knowing that you're in the headset, but you have special powers. Which button do you press?
I would probably go for the new stuff. I would probably 3 dimensions of space, 1 dimension of time feels quite confining to me. I feel like we got a cheap headset, and this is a fairly cheap simulation that we're in, and I would love to see what else is on offer. For example, when I'm trying to solve some mathematical problems, I can imagine a 3-dimensional shape, but I can't imagine a 4-dimensional shape. And we had to do some of the problems we're solving. We have to look at the geometries of things in 6 or 9 or more dimensions, and we can't just sort of imagine it and figure out what's going on. We have to crawl our way up to the geometry by theorem proof. We actually have to prove our way. So we're like blind men filling the elephant with theorems and proofs to understand the geometry. I would love to have a headset where I could just see in a glance everything about 9-dimensional space. And you can't do that with our current headset. And why stop at 9 dimensions? Why not be able to just see in 30 or 1,000 or a billion dimensions?
Do you, though, think that inherent in the way that you think about that, it still requires you to be you? Because I'll think about this a lot. If you've ever seen the movie Freaky Friday.
Oh, right.
I think about this a lot with my wife. Like, I really, really want to change bodies with her for 24 hours so that she can see what it's like to be me and I can see what it's like to be her. I think I'd be a much better husband if I really understood.
Probably so, yeah.
But the reality is the second you change bodies, I would be her.
Right.
And she would be me. There wouldn't be her as me as her.
Right.
And so even if you're right, here's what I think would happen when you take off the headset. The headset is everything you think of as you. And that even if you're right, that you can meditate your way to moments like that where you're just pure awareness. One, if you're right, all that the consciousness lives to do is cycle through other qualia. So you would either be reincarnated, meaning that you would just pop back up in a new headset, because that's what the consciousness is meant to do, is cycle through all this qualia. And so you would refragment yourself back off, you would pop up, you'd be reincarnated, you'd live life again. Or you would return to the Borg, the beehive, the ant colony, however you want to think about it. You would be reinstantiated as just pure awareness. And all of that loving and clinging and hating and attachment and precious moments and distance and all that, poof, gone. And I find that when people explore these ideas from a religious perspective, they are forgetting that they're mired in the gruesome reality of the human experience. And that to transcend that and be in heaven, for instance, and never experience pain again or whatever, you would be so different. You wouldn't recognize or relate to anybody in the same way. And so I have yet to hear any theory whatsoever other than regrowing your biological organs where you actually end up cheating death. Everything else is you die. All of the things you love, poof, go away. Maybe you're exchanging them for something better, but make no mistake, everything goes away.
Well, these are deep waters again, but here's another take on it, and that is that if you and I are just the one looking at itself through avatars, the one is learning whatever it needs to learn through these avatars, and that's not lost on the one. It is now part of the one. That's in some sense eternal. And so the reason I would, given the choice that you're asking me to make here, my own predilection would be to say, let's go for something entirely different now. Because in some sense partly because I'm inquisitive, and I would like to, what is it like to live in a 5-dimensional world? What is it like to have 20 dimensions of color and 1,000 dimensions of emotion instead of just a few that we have? What is it like? My feeling is that we have the training wheel set version right now of this stuff, really, really small. And so my guess is one possibility is that, look, you and I really are this infinite intelligence, this infinite consciousness. That's what we really are. We're peering through, in this case, very, very simple avatars with very, very simple interfaces. And maybe it's the one saying, this is fun, but when I answer your question this way, maybe it's the one saying, yeah, this is great and it's fun, but there's so much more to explore in different dimensions. Now, I haven't lost whatever I learned in this little interface, and I'm happy for the relationships and the friends and all all the things I learned about war and hate and religion and all that other stuff. All the things that go on here. But that's only a mere, in some sense, trivial projection of this entire Cantor's hierarchy of infinities of potential. This is trivial. And the potential is mind-bogglingly infinite. And so my attitude, let's get on with it. Nothing is lost by moving on. And everything is to be gained. You can see, but again, these are very, very deep waters. I'm not talking theorem and proof here. I'm now speaking very intuitively based on the science as it is in the very initial steps. I should be very, very clear. I mean, all of science has been about the space-time interface until the last 20 years or so. We're taking our very, very first baby steps outside of space-time. And so almost surely all of the ideas that we're having are going to look very naive. A century or two from now, they'll look back and go, yeah, great generation. They were the generation that stepped outside of the space-time interface. Hats off to them. But boy, were their ideas so parochial. They were shedding the interface, but boy, they didn't really understand what they were really doing. That's my guess.
All right. I actually want to spend more time in the intuitive, but is there anything from the paper, any sort of grounded mathematics that you think will ground people in your theory more in a way that will keep the intuitive exploration from just spinning off into la la land?
Well, yeah. So I'll just say in the paper I gave you, and it'll come out on June 24th. It's going to be made, and I'll tweet it when it comes out.
If you made it this far in the interview, read the paper.
Yeah, so it'll be available June 24th, and I'll tweet it when it comes out. It might be a couple days before that. I would say that one of the interesting things we're doing in that paper is we're showing how specific properties of the Markovian dynamics of conscious agents map to specific properties of particles like mass, spin, momentum, and energy. And so I'm not saying we're right, but we now have mathematically precise proposals. So, I mean, for example, these are words that won't make sense, but mass is the entropy rate of recurrent communicating classes of conscious agents.
And just to be clear, what you're saying you can predict now is particle scattering.
This is going to be for particle scattering. And by the way, the reason I'm going after particle scattering is not because I have some fetish for, high energy physics or something like that. That's the simplest place that we can make our first connections with the interface. Particles are the most elementary things that our interface has. That's why I'm going there. They're the simplest thing. I'm not going for brains first because those are countless quadrillions, trillions, whatever of particles. And so that's not the place to start. Let's see if we can get the mathematics and the experimental data for individual particles. So our paper is proposing, and maybe just so that people can show that we're wrong, we'll see. But we have, we say that mass is so-called entropy rate of the recurrent communicating classes, and that then tells us what are massless particles and what are massive particles. And so we're getting very specific predictions that we're going to be making about momentum and spin and energy and mass. So that's why. So this is where rubber hits the road, right? I'm talking all this highfalutin stuff about consciousness leading to the interface. Well, the right questions are: so what is the mass of an electron? What part of your conscious agent dynamics is going to map into what we call mass? What is the spin? Why is there a hyperfine structure in the energy levels of the orbitals of electrons and so forth? We're getting hints at answers to those kinds of questions about like the hyperfine structure. So it's really quite interesting. So again, I would be stunned if we're right, but at least we're precise, so that we can now begin the whole process of saying, okay, at least these hypotheses are precise. So now we can show their limits, try to prove where they reach their limits, and then move on. Or to show that, this is just fundamentally wrong-headed. There's nothing worthwhile. Maybe our definition of mass is just plain wrong. We'll see. But it's intriguing. It's intriguing enough that I have a particle physicist who put his name on the paper with us. Doesn't mean it's right. Doesn't mean that he's convinced that we're right. But we have a real particle physicist who thinks that if it's wrong, it's not obviously wrong, and it's worth pushing on.
Right. Yeah. I mean, I hope anybody listening to this understands how the scientific method works. I am constantly trying to tell my team, hey, you need to be fearless in the predictions that you make, because you shouldn't hold yourself accountable to always being right. You should hold yourself accountable to always learning and getting a little bit better. So the fact that you're willing to make a precise prediction, your paper is full of mathematics, and it's there for anybody to check. So people will be able to help you find the edges, which is something I've heard you talk about and I really respect about you, is that one, you obviously approach everything with humility, but two, you actively want people to find the edges of your hypothesis, your theory, so that you know where it's wrong so that you can adjust and get more right, which is far more interesting, especially if you sincerely want to understand what's outside of that headset. It's like, well, I would rather realize I'm wrong,
right,
find out how to get right so that I can actually begin to explore that possibility space versus think I'm right, but really I'm wrong, and nobody ever helps me come to understand why. I really like that, and I hope everybody listening takes that on in their own life. I think that's really important. Okay, so I wanted to make sure that you had a second to lay out the grounding there, that this is something that you're seeing in particle physics, that there really is a there to pursue, because the intuitive space for somebody like me who's not a mathematician, who, while I use the scientific method in business, I definitely do not consider myself a scientist, but pursuing the intuitive things, pursuing the thought experiments, feels true to Einstein's encouragement to all of us lay people to focus more on imagination than knowledge, right? To really understand how to begin to think through these things. So one of his famous thought experiments was that in a falling elevator, you would feel like you were weightless.
Right.
And that ends up being, it took him years, but he ends up finally putting that together with some other ideas that he had intuited, including if you're traveling at the speed of light and you turn on the flashlight, what happens? And in that spirit, you said something as you were describing the consciousness, and you as an instantiation of that, only to go back to the one. And you said, well, the one is still learning what it needs to learn. And I am like a dog with a bone with that idea. What do you mean needs to learn? Like when I think about a human,
Right.
it needs to learn
Good.
things
Good.
to stay alive because it's been given these drives by evolution.
Right.
But what has set up the consciousness that isn't physical
Right.
to need anything?
My guess, again, we're way in over my head, but here we
I love
are.
it. This is
Might
where
as
I
well.
like to take you.
The joy of exploration.
It's just pre-programmed. How it is.
It's just that the one is the only thing that there is, but it's infinitely changing, infinitely. There is self-exploration. It's really infinite self-exploration and looking and enjoying and ever expanding its understanding of itself. It's that would be my
So you
I guess.
conceptualize it as still moving towards pleasure.
well that pleasure is just in some sense it's different than an evolutionary thing. So in evolution, and I should say also concretely why it's different. This dynamics of conscious agents does not need to have an arrow of time. So that's really
Tell
interesting.
me why, because that doesn't seem true.
Okay. The entropy, one can write down a Markovian dynamics in which the entropy does not grow. Straightforward. But it's a theorem, 3-line proof, trivial proof, that any projection of that Markovian dynamics that has no arrow of time, any projection of it that loses information, say by conditional probability, it will give you new dynamics. It'll be a projected dynamics of the original dynamics, and that new dynamics will have an arrow of time because of the loss of information. So the arrow of time, so here's my view. Our experience right now of an arrow of time and of the universe with a Big Bang and then maybe a big crunch or whatever, or entropy death at the end, that whole arrow of time is not an insight at all into what lies beyond space-time. It's an artifact of the projection. Mm-hmm. And from an evolutionary point of view, right, time is the fundamental limited resource, right? If I run out of time before I get my next meal, if it takes too much time to get my next meal, it's over. If it takes too much time to get my next drink of water, it's over for me. Time is my most fundamental limited resource. So that limited resource of time is not an insight into reality. That's an artifact of projection from a timeless conscious agent dynamics. And that also suggests all the other limited resources, that's all artifacts. So evolution with natural selection is a beautiful theory, but it's the theory of all the artifacts that you see when you do a projection from a realm in which there are no limited resources, there is no competition. But it looks like evolution by natural selection in this projection. It looks like there's an arrow of time. So all of our intuitions right now about learning new stuff, it's going to be very hard for us because our intuitions are deeply shaped right now by our interface where there's an entropy arrow. And in this realm beyond, there need not be an entropy arrow. And so wrapping our heads around what it's like to have the notion of exploration where there's no entropy arrow. Now, I'm not saying I wrap my head around it, but I do know that the mathematics is there, that the Markovian dynamics does not have to have an arrow of time in the sense of an arrow of increasing entropy. So, and that's, again, one of the points of doing science with precise mathematics. I get emails quite often from people that I think are very, very bright and have really good ideas, and they don't know how to take them and make them precise. And as a result, you can never surprise yourself. You can never, like Einstein, when he had his idea about, you mentioned the falling elevator and so forth. And so he had that, I don't know, in 1907 or something like that, 1906. And it wasn't, he worked for years to take that idea and make it mathematically precise, 1915. And he learned tons and tons of what at the time was state-of-the-art, fairly new math. It was hard for him. Sleepless nights, pulling his hair out, really working hard to take his good intuition and turn. So he finally wrote down in mathematics in 1915. And a year later, a guy named Schwarzschild wrote back to Einstein and said, here's a solution to your equations. And they predict what we now call black holes. Now, Einstein didn't foresee that. He didn't like it. He didn't believe it. He disbelieved in black holes. He wanted to get rid of them. So Einstein's theory came back and surprised him. And that's why it's so important for us to do science, because what we do is we take our best ideas that we have right now, and then we make them mathematically precise. And then the mathematics comes back and it slaps us in the face and says, here are the implications of the ideas that you started with, implications that you simply couldn't think deeply enough about on your own, but the mathematics can take you where your own, just consciousness wouldn't necessarily go. And so here's one of those directions with this notion of conscious agents. The dynamics need not have increasing entropy. And so our whole intuition about an arrow of time need not hold in this realm. And so when we talk about the notion of explore, consciousness exploring for the joy of it, we're going to have to rejig how we think about the notion of, for us, exploration is something that happens in an arrow of time. What does it mean for us? Can we wrap our heads around the notion of exploration where we let go of an increasing entropy kind of thing? I don't know if we can. Maybe you just have to let go of this headset altogether to really get that. But is it possible, while we're under the limits of this headset, to wrap our minds around it? We can at least get pointers to that idea. Our mathematics led to this pointer. And I would never even gone there unless the mathematics took me there. So I would say that it's just like, the amateur astronomer with a pair of binoculars could be brighter than the guy with the James Webb Space Telescope. But he's never going to beat the guy with the James Webb Space Telescope because the guy's got better tools. And that's what science does for you. You may be smarter than Einstein, but if you don't actually put yourself using the tools of mathematics and so forth, that genius will never actually flower in the sense of reaching all the potential implications of what it means. And so that's why we do science the way we do it with mathematical precision, because for two reasons. If our ideas are good, we probably don't understand all their implications, and so the math will come back and it'll be our teacher. And second, certainly our ideas have their limits, and it's hard for us to understand what the limits are. And in good cases, the math will come back and tell us what those limits are. So, for example, Einstein's theory of gravity together with quantum field theory tell us 10 to the minus 33 centimeters, and space-time is over. It has no operational meaning. Who could have guessed? Could you have guessed? Could Einstein have guessed? Oh, yeah, I have an idea about space-time, but at 10 to the minus 33 centimeters, it's going to fall apart. Not even an Einstein could guess that. That would only come through taking your ideas, making them, doing the travail. I mean, Einstein really, it was a birthing process. It was apparently very, very hard to give birth to general relativity. And many mathematicians working in physics and so forth say the same thing. You're working in the dark, it's hard, you're struggling, and then all of a sudden, if you're lucky, you get that breakthrough and you see things. But then it comes back and you learn the limits of the basic concepts that you started with. And then you reboot from a new set of assumptions.
It's interesting that you say about the set of assumptions. So as we explore this topic, I realize that I think we still have we each have slightly different assumptions, though I think that we're talking well about the topic. But take the arrow of time, for instance. So the thing that I find fascinating about the hypothesis that you put forward is, for me anyway, I don't have the math to back it up. This is definitely land of intuition. But what I find fascinating is, if you're correct, and it's just consciousness is the singular thing, it is, for whatever reason, joy, need to pursue, desire to learn, whatever, it's
Right.
running through all of these qualia.
Mm-hmm.
And that the tool it uses to do so is this headset. There's an infinite array of headsets, but the one we're in has learned that there's only certain qualia that can be achieved when there is an arrow of time. And that's why I was saying, when you first said that, I was like, I don't know that that's true. Meaning, inside the headset, for at least certain types of qualia, it is clear. In fact, the only thing we know is that the qualia that we have access to requires the arrow of time. We presume that there are infinite headsets that provide just unimaginable, unknown types of qualia. But the type that we have directly experienced all require the arrow of time.
That's right. And that's we've been shaped basically by our headset to think that way. And if I ask you to imagine a new color that you've never seen before, you can't do it. I mean, again, it's not because there aren't. I mean, pigeons have 4 color receptors. Presumably, pigeons are experiencing colors that no human could even imagine. And maybe the mantis shrimp is seeing stuff that the pigeon can't. You know, and then the birds that see polarization of light, I mean, they're seeing something that what is it like to see polarization of light? I don't know. What is it like to have infrared vision, like certain pit vipers? What is it like to actually experience an electric field, to sense an electric field for some fish or creatures underwater? I mean, what is it like to be a bat doing echolocation? I don't know. I literally have no idea. So these are pointers to me in the headset, we get all these hints of realms of qualia utterly outside anything that I can concretely imagine.
So talk to me about near-death experiences, and then I want to get into psychedelics and whether they are simply another form of qualia of what it's like to be a human who's having that experience, or whether that's actually melting the human away and revealing something closer to being the one again. But what can we learn from near-death experiences? Do you think it's a sort of half return to the one? Or is it just, well, that's what happens in the headset to the brain when you deprive it of oxygen?
Well, from a physicalist framework, clearly the latter is the case, right? So from a physicalist framework, space-time is fundamental and consciousness is a product of the brain. And so any experiences of transcendence, of things going beyond the headset, have to be just the brain malfunctioning in its final throes of death, something like that. But if space-time is doomed, as the physicists tell us, and is not fundamental, then that leaves open the possibility. It doesn't dictate that near-death experiences are genuine insights into some conscious experiences that transcends our space-time interface. But it certainly is compatible with that point of view. And so I think it's worth, on that framework, to explore the possibility that there are some insights. And I would take any of those reports like we take any kind of eyewitness testimony, right, with a grain of salt. And you try to get corroboration and discount it. But on the other hand, you don't want to just ignore the data either, right? So there's the fine line to be open to get the insights, but not to jump on anything just because it sort of fits your preconceived conceptions. Most of our preconceived conceptions are deeply wrong. We thought the Earth was flat. We thought the Earth was the center of the universe. We thought space and time were fundamental. Wrong, 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 wrong. So we're batting poorly. So anything that, if we think that consciousness will survive death, what we think about that, the way we think about it, is probably wrong. And so what we have to do is, again, so that's why when I say we're in deep waters here and I'm being very, very careful, it's these are things that my theory, our theory suggests, but I don't want to be at all doctrinaire. I think what I should do is make bold proposals, but they're just proposals. And the goal is to be precise so we can figure out where the proposals are wrong. So in that spirit, the near-death experiences may have some good data about transitions out of this interface in that spirit.
And there's probably commonalities of what people bring back?
Yeah, there are some commonalities. There's a lot of reports of going through a tunnel, a light tunnel. Some like a review. I think Ray Moody or something like that is famous for categorizing a lot of the similarities in near-death experiences. A life review, and then of course the reports we have are people who came back. So then they came back and so forth. So there are. But there are also some that report, horrific. It's just not all reports are great. So, someone that we know personally had a near-death experience and was very, very pleasurable, and came back and has no fear. She claims to have no fear of death now. So I don't know. So yeah. Be part of the film that's exploring these near-death experiences. It's put out I think it's the Langone Medical Center in New York. There are some cardiologists who are they work with patients who die, but with new cardiology techniques they can keep the heart and the body from deteriorating for quite a long time now, an hour or something, or maybe longer, and then they can bring these people back. And so this film is partly directed by a cardiologist who was seeing so many of these experiences that he wanted to document what he's seeing in the ER. And again, I'm not going to be doctrinaire about it, but I think it's data that shouldn't be ignored, and how we should interpret it, we should be very careful.
So if that stuff is real, the prediction that seems to make is that not only is there a sense of consciousness that remains, but that there is sensory perception that holds out for quite a while. Because at least from the things I've heard, people come back with a sense of either it's peaceful or whatever, but that means that they were able to experience that and retain it.
That's right. Yeah,
this
it's quite fascinating. Yeah, again, this is exactly the right scientific way to think about it. This is data, maybe. If it is data, what does it entail about letting go of the headset and what kind of experience we might have afterwards? And is that just a transitional thing, or is it more permanent and so forth?
Right. Dude, that is so fascinating. Everything that we've talked about today, the research, all of it has really made me start to question my own thoughts around this idea. The paper's amazing. Where can people follow along with you as you continue this journey?
Well, yeah, so I do post on Twitter. My handle is @Donald D. Hoffman, Hoffman, all one word, lowercase. And every time I publish a paper, I put a link to the actual journal article. And then also talks like this, podcasts, anything that comes up, I will post those. So there, you can also, if you're a scientist, of course, you can just go to Google Scholar and type in my name. If you just Donald D. Hoffman, Google Scholar you can get directly to, I have roughly 120 publications.
Awesome. Yeah. All right, everybody. If you haven't already, be sure to subscribe. And until next time, my friends, be legendary. Take care. Peace. If you want to really go deep into this theme, check out this compilation of my best moments with Donald Hoffman.
This gives us possibly a chance to have a language which for the first time ever, we might be able to formulate a precise hypothesis about what we mean by the word God.